million developers, and they are adopting the latest version of .NET faster than ever. .NET 6 has seen nearly double adoption over the same period as .NET 5. Not only are developers adopting .NET, but they also love using it. We again are the top loved framework on Stack Overflow survey. C# is amongst the top GitHub languages, and we continue to be one of the highest velocity open source projects. Now, ever since we open sourced .NET, there have been over 48,000 contributors to the .NET repos. This is absolutely astonishing and humbling. We are truly building this together. Now, every great development platform needs an amazing community and an amazing ecosystem. NuGet is our home for library creators to share with the world. NuGet now has over 320,000 packages that have been downloaded more than 240 million times. We continue to invest in NuGet by listening to our library creators, adding new features they desire, and ensuring that NuGet is the most secure package ecosystem for all developers and enterprises. NuGet now supports features like central package management, two-factor auth, and much more. So before we get into what's new in .NET, I have to say thank you. Thank you to all of you. Every single developer that is building with .NET, building open source libraries, submitting issues, fixing documentation, or helping drive the future as part of .NET Foundation. Thank you. Now let's get into .NET 7, our biggest and most performance release of .NET. .NET 7 is a result of more than 28,000 commits coming from over 10,000 contributors. Now, as we work on .NET, we've always been thinking about what are the most prevalent challenges that developers and development teams are facing today. Safia actually spoke about this just a few weeks back at Ignite, and I think it speaks to so many of things that we thought about while working on .NET 7. Right now, many organizations are asking their developers to help them do more with less. What does this mean for .NET? To me, it means that for every feature we build, make it simple and intuitive so that you can be more productive. And for every workload we support, our performance becomes better and better so that with each .NET upgrade, you see your apps becoming more efficient. Now, performance has always been top of mind for each release of .NET, and .NET 7 is no different. For last several years, Stephen Tobe has been publishing a blog highlighting the core performance improvements with every release of .NET. With .NET 7, we are delivering more than 1,000 performance improvements, and if you were to print his .NET 7 blog to PDF, it'll be over 200 pages. We will touch on some of these improvements today, but if you haven't read one of these blogs, it is a joy. .NET 7 continues to build on our core promises of a unified development platform for building anything, especially building modern workloads, while making it simple for new developers to learn, easy for existing developers to extend their skills into new technologies, and then the most productive platform to develop with Visual Studio. While these are some of the highlights that we'll touch upon today, there is so much more to .NET that you will see throughout the conference. You can go to get.net/7 to download and get started with .NET 7 right away. Now, one of my favorite things about the annual cadence of the .NET releases is that our programming languages also get brand new productivity feature. C#11 is here along with .NET 7 and brings some of the great new features for developers, including generic math, support for required members, and raw string literals. With .NET, our goal is to ensure that developers have a delightful experience building for the web, be it full stack web apps or web APIs, building powerful cloud-native apps that scale with your business needs, or building client applications that can run across desktop and mobile devices. We'll cover some of the key features across all these workloads this morning, but you'll hear a lot more about them and their roadmap throughout the rest of the day. So let's start with building for the modern web with .NET. The modern web requires three critical things: a powerful runtime, a capable set of APIs that can power anything, and the elements to create a stunning website. In .NET 7, we deliver on this by adding support for HTTP3, rate limiting, route grouping, and several other improvements across the spectrum for developing web APIs and web applications. There are so many key areas to the web for .NET that right after the keynote, you will hear from Daniel Roth in the State of ASP.NET Core session, where he will go deeper in each of these areas. For now, I will focus on APIs and the investment that we have made in these. Now, when I think of APIs, I think about how they are truly everywhere and powering everything that we do. APIs are mission critical to organizations, small and large. Take, for example, this event. There are several APIs required strictly for bringing the stream to you. However, when you add up the website, social platforms, and the communication stacks, there are hundreds of APIs powering all different types of applications. This is why we care so much about APIs built with .NET. We know they are the backbone to so many amazing applications, and they are truly powering the world and the applications that we all use every day. Our mission is to ensure that APIs are easy to create and maintain, they are secure, they scale, and they are hyper-fast. How fast, you may ask? Well, they are blazingly fast. .NET API performance has been at the top of the charts of Tech Empower benchmark for years. With .NET 7, we continue to push forward to squeeze every ounce of optimization we can, and the team has improved on .NET 6's performance now by reaching over 7 million requests per second, which is around 11 times more than what Node.js achieves on that benchmark. Now, when it comes to throughput, it has been our big focus, and for JSON serialization, we have improved it by about 16% over .NET 6. Now, in fact, at this point, we've hit the limit of the network card that is used to measure these tests on the Tech Empower hardware, which is just incredible. Now, when working with APIs, we know that it is not just about throughput. APIs must interact with the backend services and databases, all of which impact the end-to-end performance. Therefore, we continue to invest heavily in Entity Framework Core, the object relational mapper for .NET that enables developers to interact with a whole wide range of databases, including SQL, Cosmos DB, Postgres, and many more. In .NET 7, we've not only added several new features like distributed transactions and mapping to JSON columns, but have also worked on increasing the throughput of working with data all the way by up to 74%. So things will be more than 4x faster in certain scenarios. Now, even though we often talk about REST APIs, you can build all sorts of different APIs based on what your application needs, including gRPC for hyperfast communication between servers or server and client. With .NET 7, gRPC is now faster than ever. It is not only significantly faster than .NET 6, but also best in class. We are pushing the boundaries of what you can build with .NET and ensuring that it meets your and your customers' needs. Now, with all of these enhancements, it doesn't mean things have to be complicated or hard to get started. We are focused on ensuring everyone can build amazing APIs with .NET quickly and scale to add powerful features as they need them. With .NET 7, building these APIs is lightning fast, as we have fine-tuned the framework to help you build APIs that are minimal, powerful, and secure. Now, we've added new features like the Map Group API to easily scaffold out full REST APIs in the most minimal lines of code and enable developers to structure the code more efficiently. Authentication is another key area in APIs that is so important. Based on feedback from developers, we have significantly simplified authentication, making it just a single line of code and a method to call. Well, that was a lot, and it is time to see some of this in action. Now, let me introduce Safia and Julia, who are going to show you some of these enhancements and what else you can do with .NET APIs. Over to you, Safia and Julia.
Thanks, Gaurav. Now, in last year's .NET Conf, we showcased the .NET Podcast app, which allowed users to listen to podcast episodes via a mobile app and a web app. Today, I want to hone in on the API that makes this experience possible and show you some of the new features that we built in .NET 7 to make building APIs fun, productive, and powerful. Now, I'm going to jump into my editor here and show you some of the code for the existing podcast API. One of the things that I'm observing is that the code uses several different strategies for registering routes in our application. Here I see that we have map action calls in our program CS, we have got a shows controller, and we've got some endpoints that are registered under an extension method that is called from our program CS. Now, this is fine. In fact, it's pretty cool because it shows how different endpoint invocations can interop with controller-based APIs. But for the sake of myself and some of the other developers on the team, I want to clean up the code that we have here, make it a little bit more dry and easy to read using a new feature we shipped in .NET 7 called route groups. Now, so we're able to see the before and after code without route groups and code with route groups. I'm going to create a new minimal API project in my solution. Right-click, add, new project. Once I've selected the API option, I'm going to be able to customize a variety of settings in my application. Whether or not I want support for HTTPS, I do. Whether or not I want to enable Docker, I do because it fits into our deployment story. Whether I want to use controllers, I don't in this case because I want to use minimal API-based endpoints for all of our applications. And whether or not I want to enable OpenAPI. Once I've created my application, I want to use the scaffolding tool in Visual Studio to create endpoints backed by entity framework models in our application. So let me go ahead and show you what that looks like. I'll go ahead and right-click, add, new scaffold item. And here is the magic option, API with read-write endpoints using entity framework. Once I've selected this option, I'm able to select a backing model for the endpoints that are going to be generated by my API. Here I'm picking the weather forecast model that's part of the base template. I can choose to generate a new endpoints class, as well as generate the data context classes needed to support my new API. Now, what does the generated code look like? Let's take a look at that really quickly. Aha! This is what I want to see. The generated code is taking advantage of the new map group API in minimal APIs. Map group allows me to create groups of routes that share a common prefix, in this case, API weather forecast. Once I've created this group, I can apply different invocations to it, such as with OpenAPI, or require authorization to add OpenAPI or add authentication to all of the routes in that group, providing me with a much drier experience for writing code. I love this pattern, and I've honed in on using the scaffolder for all of the different resource types that are defined in our application. Here you can see I've generated a categories API that allows me to generate our get categories route onto a route group, and I have APIs for episodes as well as shows. Now, one of the pieces of feedback that we got from last year's .NET Conf was that users would love the opportunity to submit show ideas that should show up in the podcast app. And to that end, we want to add a new set of endpoints to our application called feeds endpoints that will allow users to submit feeds that they want to show up in their API and allow an administrator to approve or deny feed submissions. So I've gone ahead and written up the code to support this API. I've got one post endpoint, a get, a put, and a delete. With route groups, this code is dry and easy to read, as you see when invoked in my program CS. Now, I want to drill a little bit more into this feeds endpoint and show you some of the new features that we shipped in .NET 7 to make building APIs more secure and reliable. I mentioned that this feeds endpoint will support submissions from external users. Now, I want to lock things down a little bit and make sure that people aren't able to abuse the API. To that end, I've added support for rate limiting in my application using the new rate limiting APIs. Rate limiting allows me to configure rules that will limit the number of requests that can be sent to my application over a fixed time window. Here I'm doing this by invoking the add fixed window limiter option. Rate limiting supports a wide variety of customizations that you'll be able to see later in the conference, but for now I'm getting started with this basic model. In addition to rate limiting, I also want to make sure that only admin individuals can deny or approve feed requests. So I need some sort of way to add authentication into my application. I'm going to leverage Azure AD for this by introducing the Microsoft Identity Web Package and configuring authentication using just 2 lines of code. Here they are. The first line of code enables Microsoft Identity Web-based authentication. The second line of code adds an authorization policy that requires that people be able to present a particular API scope when sending requests to my app. Now, I've talked a lot about the code, but I haven't yet showed you what the API actually looks like when we interact with it. So let's go ahead and run our API. Cool. This is our trusty Swagger user experience that we can use to interact with the API. You saw this in last year's .NET Conf, but I want to draw your attention to this Authorize button in the top right corner of the screen. We've detected or inferred that this application has authentication enabled. And with this authentication enabled, we can provide a bearer token that will be sent for any request transmitted from this UI. But I don't have a token handy to use as I'm testing this API locally. Or do I? In .NET 7, we introduced the new .NET User Dots tool, which can be invoked via the command line to generate tokens for local testing. Here, I'm invoking the .NET User Dots tool to create a token that matches the audience and claims that are expected by my Azure AD provider backend. Once I've acquired this token, I can copy it into my local UI for testing. And check out what happens when I hit one of the delete endpoints with some sample data. Pass in an ID, hit execute. We'll observe that the authentication API has sent over the token in the bearer in just a moment. Oh, I know why it's not happening, because there's a breakpoint. We'll hit continue there. Aha, this is what I want to see. We've transmitted our token via the bearer, and here's the expected response. We're able to see the end-to-end of interacting with authentication locally in my application. I'm really excited with what I did with the Feeds API. I've secured it with authentication, and I've ensured that it's resilient against abuse with rate limiting. I'm going to go ahead and deploy this to the cloud. And Julia, I hear that you have some things to show us about how we can supercharge our API when it's in the cloud with Azure API management.
Awesome, and thank you, Safia. So with an API-first strategy, APIs can go everywhere, and we can empower everyone. With our next demo, we want to demonstrate you how easy it is to consume .NET REST APIs from different kind of platforms. Azure API Management as our management platform for APIs is one example of these consumers. But we can also light up platforms like Microsoft Teams or the Microsoft Power Platform and enable cross-platform scenarios. So for my demo, I'm going to jump right into my Azure API Management instance. After deployment of our web API, we first have to add our API to our Azure API Management instance. We have lots of different options, so no matter what type of .NET API you're building or where it is hosted. Currently, Safia's web API is living in an Azure Container app, so we were able to import it from one of our Azure resources. So we were able to import it and called podcast.minimal API. Azure API Management then pulls in our API and leverages the names, the tags from OpenAPI. We can also set up a policy to modify our request before going out to our backend service and make it even more secure before other consumers like the Microsoft Power Platform interact with our web API. But before we want to expose it, let me first show you how we can test our web API within the portal. For this, I'm going to hit the testing tab right here, and I'm going to choose the get feeds operation and hit the send button. As you can see, I'm getting a 200 and all of my responses in the body here. I'm going to copy one of the IDs, and now I'm ready to expose it to the Microsoft Power Platform. For this, I'm going to switch over to our Power Platform tab right here. And from here, as you can see, I can easily create a so-called custom connector. A custom connector is basically just a wrapper around a REST API that lets users of the Power Platform communicate with our web API. As soon as I hit the Create button, a custom connector will be created on the Power Platform side. So after this has been done successfully, I can then switch over to my Power Platform portal and under Custom Connectors, see the web API we just exposed. because we implemented authentication on our API level, I want to make sure this is also configured on the Power Platform side here. And just like Safia, we chose OAuth as our authentication type, and we also selected Azure Active Directory as our identity provider. Now I'm ready to also test it within the portal right here. This time I want to test my delete feeds operation just to make sure authentication also works here. So I'm going to paste in the ID and I'm going to hit the test operation button. And as you can see, I'm getting a 2 of 4, so this podcast has been deleted successfully. So now that we tested it in here, let me show you what this will look like if we want to consume a web API from a Power App itself as well. So some of you might be wondering why we are using Microsoft Power Apps. For our use case in particular, we needed an internal application for some of our admins. We chose to use Microsoft Power Apps to get our job done as quickly as possible without having to worry too much about a lot of front end or writing a bunch of code. The important thing is we are able to communicate with our .NET REST API and enhance functionalities of the Power App as well. So before I can make an API call, I first have to make sure we have imported our custom connector. Now I'm ready to make an API call. And this can easily be done by just simply referencing it up here in the formula bar. And as you can see, I'm calling the custom connector's name and the operations name. But let me show you what this will look like in action. I'm going to hit the play button. I'm quickly going to refresh the dashboard because we deleted one of the podcasts while testing. And now if I hit the approve or the delete button, one of the podcasts should be deleted or approved. Here you can see I successfully deleted one of the podcasts. So while testing, I noticed that we are not getting any return message here. So Safia, I was wondering if there's an easy way for us to show any of the upcoming requirements.
Great feedback, Julia. You're right that when a user deletes a feed, they don't get any message indicating that the feed was successfully deleted. So I'm going to head over to my screen here, and you'll see that I've made the necessary updates to the delete endpoint. We're going to return a message now whenever the user deletes a feed. Now, usually if we were going to test this, Julia, we would have to deploy to staging or production and go through a whole process just to validate that my change works. But there's something new in Visual Studio that I want to use that I think will help us out here. It's called def tunnels. I enable it by setting some flags in my launch settings. You can see them here. And what's going to happen is as I'm running my application, I'm going to get a unique URL. When you access this URL and send requests to it, they're actually going to be tunneled to the API running on my local machine. So we'll be able to see the interaction end to end. And in fact, I want to test this out right now by setting a breakpoint in the API that I just changed, which I hope will be hit. And I'll go ahead and share that URL with you over Teams. Let me know when you've got it and we can try this out.
Yeah, awesome. I got it here. I'm going to switch back over to my Azure API Management instance and change one of my backend runtime URLs. So I'm going to replace the current runtime URL, and I'm going to paste in the def tunnels URL here. I'm going to hit the save button. And now I'm going to switch back over to my Power Platform portal here.
Yeah.
So as soon as I'm also going to copy one of the IDs you shared with me earlier. So as soon as I should hit the test operation button here, we should hit a breakpoint on your machine.
Yes.
Are you ready?
I'm so ready. Here we go. I've hit my endpoint. Is the feed that you deleted one that begins with B57?
Yes.
All right, Julia, so you should get a string back. I'm going to hit continue on my local editor here. Let me know if the message you get back looks good.
Yes, awesome. I can see a 200 and I can also now see the return message here right in my body.
Sweet.
So with the dev tunnels in Visual Studio, Safia and I were able to collaborate even faster. We connected Safia's web API running on her local machine to my web service by just copy-pasting the dev tunnels URL. Dev tunnels enable developers to create an endpoint to their local machine and generate and provide a seamless debugging experience for Power Apps, webhooks, Blazor web applications, and many, many more. With just a few configuration settings, you can enable this. And now back to you, Gaurav.
Yeah, thank you, Safia and Julia. It is incredible to see all these enhancements in action. And just to summarize, I think you were talking about dev tunnels, and how they make the developers so productive while working with APIs. Now, it is incredible to see all these enhancements in action and how .NET 7 will enable developers to build rich and powerful APIs. Now, we want every developer to be able to take advantage of these new features, which is why we are on a mission to help developers easily upgrade to the latest .NET. We have built several tools to assist with the process. First is a tool that enables you to incrementally upgrade from ASP.NET Framework to ASP.NET Core. This tool helps you set up an ASP.NET Core app in front of your existing ASP.NET Framework app using YARP or yet another reverse proxy, and helps automatically route requests between the two. You can move endpoints and pages to the ASP.NET Core app one at a time while you continue to develop and maintain the existing functionality. Now, for a wider range of .NET applications, you can use the .NET Upgrade Assistant. That is being used by more and more developers to move to the latest version of .NET. The Upgrade Assistant is built in the open, and in .NET 7, we've added support for new app types, new analyzers, and so much more. There is really no better time to upgrade than now. Now, throughout the year, teams across Microsoft have been sharing these stories about their migrations to the latest version of .NET, the performance gains that they have seen, and all the savings that they have been able to leverage by upgrading to the latest versions of .NET. Now, I want to tell you about one of these stories, about Microsoft Graph as they migrated to the latest version of .NET. Now, Microsoft Graph is an API gateway that provides unified access to data and intelligence across the Microsoft 365 ecosystem. The service, as you would imagine, needs to run at scale and at a very, very high scale, right? 4 years ago, they were on .NET Framework, serving around 1 billion requests every day, but had extremely high operational costs, so they started migrating, first from .NET Framework to .NET Core 3.1, then to .NET 5, and currently they run Microsoft Graph on .NET 6. Today they serve a staggering 70 billion requests per day. That's almost a 70x increase. Additionally, the operational costs were reduced by about 91%. With every upgrade, they saw improvements, but the biggest gains came from that first move from .NET Framework to .NET Core. Now, we want you to take advantage of the similar benefits for your .NET projects. Upgrade to .NET 7 today. Now, this is just one example, and I encourage you to read a lot more stories from teams here at Microsoft and companies across the world that are building with .NET. And if you'd like to share your story, please do reach out to us. Now, one of those companies is the world's largest scavenger hunt, geocaching, headquartered right here in Seattle. You may have heard of geocaching, or maybe are a hardcore cacher yourself, but did you know that .NET powers geocaching, the game and the company? They have chosen .NET for over a decade and continue to invest to stay current to take advantage of everything we have talked about today. We had a chance to speak with them recently to tell us more about their .NET journey and how .NET APIs have enabled them to grow and scale over the year. Let's roll the video.
Geocaching is a game of hide and seek where people place boxes around the world and other people try and find them. Geocaching started in a basement. There were 3 of us that founded the company.
It was a web-only experience. We had GPS devices that we would use in the field.
When mobile came around,
We grew from serving thousands of people to now millions of people. We had to learn how to scale really fast. .NET allowed us to build web APIs to scale our website so we could serve customers as we grew. Now, our entire backend is built with .NET web APIs.
Our API supports millions of customers around the globe, and it's 24/7. That's actually more than 1,000 calls per second. We have over a billion of geocache logs recorded in our system. Our API supports over multiple dozens of partners, as well as our internal client, including our mobile app and our websites.
It's always been really easy for us to upgrade .NET. We've had good luck with LTS versions and also non-LTS versions. They both tend to work seamlessly. I'm really excited about the .NET 7 release. I know there will be improved security, there will be improved performance, new tools, and just an overall better coding experience.
.NET has been the cornerstone for us because it's been helping us grow and scale along with our customer base.
It's reliable, it does what I want it to do, it's secure, everybody knows how to use it, it performs. It's my favorite platform.
It is incredible to see what developers across the globe are building with .NET. And now to tell us more about how developers can build scalable cloud-native applications, I have my friend here, Scott Hunter, to tell us more. Scott, over to you.
Thank you. Cloud native is a term you hear all the time today, and we're here to tell you that .NET is the best tech for building cloud native applications. So let's go forward here. So basically, we estimate that by 2024, over half of the companies out there will be building apps using cloud native technologies. This means that you can build apps that can scale to meet any demand. It means that your apps are super resilient, and it means that your apps can be built faster and faster. Cloud native apps. So 60% of apps, developers are using containers. We're going to talk a lot about containers because I'm a big fan of containers here, and .NET is amazing for containers. Backend developers are using cloud native technologies, 41%. And then 66% of cloud native developers are building microservices. And .NET is great for all of these things. Whether you're building containers or Linux support or APIs, we are one of the best technologies for that. So what I want to talk about now is show you Canonical and their support for .NET. Let's roll the video, please.
Developers want smaller container images to use in production. They want higher performance, lower cost.
We wanted to reimagine containers as being super stripped down, appliance-like. And so we came up with this idea of chiseling. You just grab .NET on Ubuntu, build an application, and then turn around and chisel it, get rid of everything that you don't absolutely need for that production environment, but still leave those slices in the chiseled Ubuntu container, which support the production runtime use case. So small containers enables cloud native developers to build applications that can be deployed faster and scale much faster. It's also more secure because there's less in it to attack, and it's going to use fewer resources. It's going to be more cost effective. It's going to use less energy.
We also set up a zero-distance secure supply chain, and it gives you an additional level of security. Now, Canonical drives VM images and container images to Azure, and then on their way back, they take all the .NET source back to Canonical so they can build the .NET packages. .NET in Ubuntu is updated on the same schedule as everything else, and then no one gets 0 day.
And the teams are working together to make sure that .NET 7 is available right now to open source developers on Ubuntu. .NET is, for me, a platform that will unlock the next generation of applications. It feels like now Ubuntu really does everything that a cloud native developer needs to kind of bootstrap and be productive.
So that's amazing. So think about this. .NET is now in the box in Ubuntu. Starting with Ubuntu 22.04 LTS, you can basically apt-get or apt-install .NET into that. What you get, you're getting enterprise-level support for Ubuntu. You're getting same-day update for patches. We have support for both x86 and ARM64 in Ubuntu, in .NET 6 today, and .NET 7 is right around the corner. And so I'm super excited about this. I mean, .NET doesn't just do Windows, .NET loves Linux. Even better, if you're building containers, which is the form of all future deployment to the cloud is going to be containers. And if you look here, we support .NET and chiseled Ubuntu containers. What are these? These are distroless images. So it's the smallest size container you can get here. Why does that matter to you? Quicker to pull, quicker to deploy, quicker for all of those things. Also, these are the most secure containers you're going to get because there is no shell, there's no package manager, there is no root user. We've ripped all that stuff out. It's just your application. And you can see here on the graph, look at that, 104 megs for ASP.NET web application running in the containers. And something else, we are living in a world right now, ARM64. It's everywhere. Whether it's an Apple M1 Mac, we just announced the Volterra development machines a few weeks ago as well for Windows. ARM is everywhere, and we want to make sure .NET runs best on ARM. So you can see here, we have our performance is on par with x64. We have native support in Visual Studio. You can actually now download a Visual Studio and run it on an ARM64 Windows machine, and it will just work as native ARM64. We have native support for .NET Framework 4.8.1. So even if you're on the older technologies, it doesn't matter. Your applications are completely able to run natively on ARM. And then basically, .NET scales to wherever you want. You can see from the charts here, tech-empowered JSON support is just as effective on ARM as it is on x64. The latency is just as good on ARM as it is on x64. So you can see our continuing investment to make .NET work everywhere the best that it can. And of course, we love containers. I love containers. One of my favorite features of .NET 7 is the built-in support for containers. It used to be that you had to turn Hyper-V on a Windows machine. You might have to install Docker for desktop. We don't want you to do any of that stuff. We want containers to be as simple as doing a .NET build. And so you can see on the command line here, I'm basically doing a .NET publish, and I'm telling it to use a publish profile that tells it to build a container, and it'll just build you a container with nothing else on the box. And so our goal here is not only to let you have great support for Linux in .NET, but to make it so it's as simple as building a regular app on your machine to build a container. We're trying to take all that work out and make you more productive. And with that, I want to hand off to David and Chet, and they're going to do some amazing demos of containers in .NET.
Thanks, Scott. Couldn't be happier to show this off. I'm super excited for this feature as well. Containerizing can sometimes be difficult, as Scott said. There's a whole bunch of knobs to get right. The good news is the .NET SDK knows most of these knobs already, so we can help you package your container quickly, easily, and effectively. With some new APIs that came in the .NET 7 runtime, we can even do this without any external tooling. Let's see what this looks like on an actual application. So in my PowerShell session here, I'm in the .NET podcast application that Safia showed a little earlier. It's been rewritten to use some of the new features in ASP.NET on .NET 7, and because of that, we can use our new containerizing features. This is the command that does the deed. Let's run it and see what we've got. So all of this should look very familiar at this point. It's a normal build, but wait, look at all of this output. You're seeing things like image names. You're seeing things like tag versions. You're seeing things like base images. These are all concepts that should be familiar if you've containerized before, but they're happening inside the .NET SDK. And then later on, you can see that we're uploading these things called layers to a registry. This is everything that you may be used to with other containerized or containerization technologies in one command. And even bonus, look, no other applications running. That's crazy to me. Let's look at what it what you have to do in your projects to get this up and running. So like I said, we are in the minimal API project on the .NET podcast application. Let's take a look at our project file. We'll clear out some extraneous information and look at the core pieces of it. So this functionality is delivered through a package reference right now. This package is called Microsoft Net Build Containers. You can add that through the NuGet UI in VS, through .NET Add Package, or any other way that you're used to adding packages. Once you do this, you will get access to that publish command that I just ran. And if you don't specify anything else, we will infer all sorts of information about your project to pick the correct base image, the correct container name, and then we will publish that to your local Docker daemon. So by default, you get something that you can run and you can verify. But you are in full control here to customize all of those parameters as well. The image name, any tags that you want, even the registries to upload to. And if you choose to upload to a registry, the SDK is there for you. It will understand all of the existing Docker authentication mechanisms that you're used to, and it will take that information and authenticate to those registries to do that upload. In fact, that's exactly what we saw here on the command line. Before we started, I'd logged in with ACR login to my Azure container registry, and that's what made this push happen. So for right now, you have to add this package reference, and that's a bit of a step. So what we're looking for in the future is to bring this functionality directly into the .NET SDK. We're also looking at expanding our support for the kinds of customizations that you can do, specifically around users and groups in the containers. And this will really unblock our full support for those chiseled containers that you heard about earlier. We will also be looking at expanding the set of authentications that we understand so that we can more fully support the broad array of registries that exist. So that's the core technology. But let's look at how Visual Studio can build on that to deliver a compelling user experience for the tens of thousands of Visual Studio publishes that you all do every year. So we have our application here, and we can do the right-click publish gesture that we're used to. And we can make a new publish profile for this. And because this application is Dockerized, pushed to Azure Container Registry, and then deployed in Azure Container Apps, we want to see if we can do that automatically as well. So some of you may have seen this flow before, but we are going to choose the Azure Container Apps workflow, and we're going to pick some of the existing subscriptions and some of the existing Azure Container Registry registries to push to. Oh, whoa, this is new. This is different. I have a choice now. I can containerize using the .NET SDK tooling, and VS is telling me it will understand that. So let's do that. And then let's do a CI/CD workflow. When we generate this workflow, we'll go through it, but what this will do is give us a firm foundation for our entire team to build upon. So what we'll see here is a full-featured foundation. This is going to push on every, or it's going to run on every push to main, and it's going to do all of the, so many steps that you have to do to correctly log in and containerize and build your application. So it's going to log in to that Azure Container Registry that we chose before, and it even has done the hard work of acquiring the secrets necessary to make that work. And then it's going to do the publish, which looks very similar to what we just did on the command line here, even specifying the same profile, specifying a custom tag to make sure that we don't overwrite the tags, and then specifying the registry. So it knows how to use this new technology effectively. And then it will, then continue on to actually trigger an Azure Container App deployment of that container instance that we just pushed up. So one thing that we can do is we can actually go see the container in the registry. And we can verify that that push that just happened did in fact happen. So if we go to our container registry and we look at our repositories, and we can look at the podcast API, and we can see that 1.0.0 was pushed up just a minute ago. That's fantastic. So we've shown how we can containerize, and we've shown how we can generate a good CI/CD workflow as a foundation for our team. I think we're done. I think we've published. Let's go see what things look like in the real world. David, you want to take a look?
So now I don't have to learn YAML anymore. Right?
No,
awesome.
you don't. It's amazing.
Cool.
Just XML.
The app is deployed. It's in Azure. We should be done. We can go home with our lives, be done with the Keynote, and be over. Let's make sure it scales for when the app goes viral. I'm going to run a load test right here on the command line. I'm going to hammer the backend API with a bunch of load. Let's see if the app still works while it's being hammered with load. I'm going to try to sign in, and sign in, and sign in, and hopefully, eventually it will work. It seems like the app is dying. This isn't great. Our cloud-native web scale app isn't working at scale. Let's try to figure out what is happening. I'm going to open up the Application Insights dashboard to get an overall view of my application's health. You can see here I see a bunch of failed requests. That's not great. I'm also seeing the server response time going up really high. In fact, as high as a minute. The app is actually still spinning. Not great. Let's dig in and see if we can figure out what's happening with the application right now. The server response time shows me an overview of all the slow requests in the application. You can see the shows request seems to be the slowest, as slow as 12 seconds. So we have 14,000 samples of this request. We don't sample every request. That would be very slow. We pick a subset of those requests to sample. And I can dig into this request, the shows request, and try to find a good request to zero in on so we can see what's happening with the application. Why is it slow? 1.7 minutes. That is insane. Let's see if we get a good trace here. Oh, this is a good one. OK, so I'm going to minimize this. And we can see here a distributed trace of the shows requests, showing me all the requests to the backend database, and for some reason, a bunch of requests to other endpoints. I'm not sure what this is, but this gives me a big clue as why it's slow. Top10devs.com apparently failed. So we have one clue so far. We have this trace. Let's see if we can find more information to figure out what could be happening with the application's performance. Now I have a second dashboard here that I made called .NET Performance Dashboard, which is going to show me all the metrics for my application. So I have the threads and thread pool. I have the ASP.NET Core requests, info about the garbage collector, and locks. Now, I see that whenever there's a spike in requests, it tends to correlate with a spike in threads. That's the opposite of scaling cloud native. What I want is my threads to be low when the requests are high. I need more money, more users, and I want my app to perform well. So we have our second clue. We have metrics that are showing high threads, and we have the trace showing slow requests. Let me show you how we actually turn on these metrics for the application. If I go to the code in Program CS, you'll see I have wired up OpenTelemetry, which is an open source library that is used and becoming the industry standard for how diagnostic information gets from applications into tools. I'm configuring distributed traces, metrics, and logging, and I'm saying where I want it to go, Azure Monitor, and what I want to collect. So I'm collecting HTTP client information for outbound requests. I'm collecting stuff for the database and for ASP.NET Core inbound requests. So you can see this pattern for tracing, for metrics, where I'm also sending to Azure Monitor, and I'm sending it to Prometheus, which is an open source database for metrics. And I'm collecting all the information required from the application and the core runtime libraries so we can get info about how to debug the application. Last but not least, I can send fully structured logs to Azure Monitor by configuring logging to be sent there. So I have distributed traces, metrics, and logging. But I still don't know what's happening in the application. So we have two clues, but we need to figure out exactly what's happening. So what can I do? Good news, Chet setup, good job, Chet. Chet setup on Azure Container Apps, a sidecar container, .NET Monitor, that we're going to use to collect deeper information from the running container in Azure Container Apps about what's happening. So we've configured a bunch of environment variables. Are kind of boring, it's kind of insane, that will collect a process dump and collect all the stacks from the application, the API, whenever we see a high thread pool queue length. The graph we saw earlier showed a super high queue length of I think 300. Mm-hmm. So when it's over 10, for more than 10 seconds, we want to collect information to do a deeper diagnosis. Now, when you collect a dump, they're typically huge, massive, right? Could be gigs in size. I want to show you an example of that, actually, if we go into blob containers. So we're sending these dumps and stack traces to Azure Blob Storage. And if you look at the size of these dumps, they're gigs in size. So that's a small one. The big ones, if I sort by size, that's not the size I want.
Descending.
Oh, yeah. So a 2 gig dump for this very small application. So typically, you don't want to pay for bandwidth to actually get these dumps to my local machine. So I can use stacks to quickly diagnose what might be the issue in the cloud. I actually did it beforehand. I actually have a dump in VS Loaded for the Keynote, obviously. And I'm going to run an analysis on this dump to hopefully figure out what's wrong. All right. So this dump came from the Linux container, and I put it onto a Windows machine, and we're going to put it into VS, and we'll see what happens, right?
That's mind-blowing to me.
All right. So now I'll click Analyze. And it's going to run, and it will run a bunch of rules over the dump. And it says there's a blocking call on the thread pool that may cause starvation. All right. So VS told me there's 78 threads blocked in this method, the shows API, where we had a hunch, right? I think it was wrong. And it says this may cause thread pool starvation and hangs. So I'm going to click here, and it's going to pinpoint the exact line of code where the issue is. And of course, when we're getting all the shows, we're making a request to make sure that the show's link is valid every time it happens for every single show. Not great. But then we're also doing .result, sync over async. This is the issue. So I should be able to delete this whole line because we should be checking the show link on ingestion, not on read.
I'm just going to say, don't get blamed that line of code, please.
I won't blame you on stage. So yeah, so that's it. I should be debugging now. And that was the whole thing. So we saw you build a container without a Docker file. We saw me diagnose a production application with OpenTelemetry support. And finally, we used VS to pinpoint the line of code where the issue was. That is the power of cognitive.net.
Oh, yeah.
Back to you, Scott.
Thanks, that was amazing. And just to recap, .NET loves Linux. We just said that we're now in Ubuntu. We're also in Fedora. We're also in Red Hat. And so you can see the Linux community is embracing .NET. We just showed not only can we run on Linux, but we have great diagnostics on Linux as well. And then finally, we showed that .NET loves containers. We have great support for no longer requiring you to put a Docker file in. You can just publish your app right to any of the container things that we have in Azure. And if you look, Azure is the best cloud for running cloud-native applications. But I want to focus on just what we do for containers. We have a couple of ways of hosting your containers of .NET in Azure. Number one, app service. We have app service can run Windows containers and Linux containers. Then we have Azure Kubernetes Service. This is if you want to have massive scale .NET running in Kubernetes, we support you there. And then finally, we have the newest edition, which is Azure Container Apps, which still runs on Kubernetes, but we actually manage that for you, and you just focus on your applications. And with that, I'm going to hand it back over to Gaurav to talk about the rest of what's new in .NET 7.
Yeah, thank you, Scott. This is, I just want to finish this morning by talking about our investments in enabling developers to build client applications across mobile and desktop. Now, .NET MAUI is a unified development framework for .NET to build beautiful cross-platform apps for iOS, Android, Windows, and Mac, all from a single shared C# code base with access to native platform APIs and delivers native performance. We continue to rapidly iterate, bringing several enhancements to .NET MAUI in .NET 7, and I encourage you to see the State of the .NET MAUI keynote later today, to catch up with some of those enhancements. Now, we released .NET MAUI earlier this year at Build, and it has been really fun to see what you all have started to create with this platform. The ecosystem around .NET MAUI is starting to flourish with community packages and amazing control vendors enabling developers to build beautiful applications. We are also starting to see companies around the globe trying out .NET MAUI to adopt it as their multi-platform framework of choice, including teams internally at Microsoft. Now, for building client applications, developers like to have choices. Selecting the right stack often comes down to reach versus depth, and it's a sliding scale. .NET supports this entire spectrum. Today, Blazor allows you to build full-stack web applications like PWAs with .NET, with a choice to have the code running on the client via WebAssembly or on the server. With .NET MAUI, you can build native cross-platform applications across desktop and mobile. And now you can also build hybrid client applications that bring web and native together by using Blazor alongside MAUI, all with .NET. We are continuing our investments in all of these key areas, so no matter where on the sliding scale you want to be, .NET has you covered. Now, as I mentioned earlier, we are doing something really special at the conference this year, which is the introduction of state of the platforms. Throughout the day, you will hear directly from the product teams behind ASP.NET Core, .NET MAUI, and Azure for .NET in mini keynotes to go over topics in even deeper detail. I hope that you will watch these state of the platform talks, and of course, all the amazing talks here at .NET Conf over the next 3 days from teams here at Microsoft, as well as our global .NET community. Now, alongside the release of .NET 7, we have also released the 17.4 version of Visual Studio 2022 with support for .NET 7 and the latest C# 11 features. It comes with improved performance, AI-assisted programming, and deep integration for cloud-native development. If you're developing on ARM64 devices, this release has full ARM64 support as well. Now, version 17.4 of Visual Studio for Mac 2022 is also shipping today with tons of great enhancements for .NET developers, including the finalized tooling to support .NET MAUI. You can go to visualstudio.com and download it today. Now, let me close this morning by thanking each and every one of you, whether you are already building on .NET or are just thinking of getting started. You can go to get.net/7 to download .NET 7 today and get started with building amazing applications. Thank you so much and have a great .NET Conf.
What a way to kick off the 12th ever .NET Conf. Welcome everybody. Thanks for joining this morning or afternoon or evening, wherever you are. I am Maddie Monaquilla.
I'm Matt Sokup, and we couldn't be more excited for today. It's an all-day learning experience. We started an hour ago, and we're going to go all the way for another at least 8 hours, and then tomorrow, and then Wednesday. It just keeps on going.
It just keeps on going all the way. And of course, yesterday there was the amazing Student Zone, where a bunch of you tuned in to watch us all day and learn about different .NET technologies. So if you came back today for your second day, thank you. We have so many things going on with this conference. If you go to dotnetconf.net, that is your landing page for all of the amazing things you need to know.
Yeah, absolutely. And there's a bunch of stuff going on at dotnetconf.net. You can take a survey. Tell us how we're doing.
Yeah.
You can register. Our great sponsors have swag bags. I think there's 25 swag bags that you can register to win. There's just a ton of other stuff going on there as well. There's a code, like a code challenge that you can take.
The secret decoder challenge?
Yeah, absolutely. And then tonight, Maddie, what's going on, I think at 5 o'clock Pacific time, is Jeff Fritz and Richard Campbell are going to have a attendee party. It's going to be a coding jam. It's going to be awesome.
That sounds fun. As you heard from Gaurav, there's a new layout to .NET Conf this year. We're doing these State of the Union, State of the Platforms. And so we'll start it off in a couple minutes with Dan Roth and ASP.NET Core. And I believe you are doing something in this section or in the Azure section?
I'm doing something in the Azure section. I am all about the cloud. I'm all about .NET, and I can't wait to talk. It's going to be a whirlwind tour. Maddie, we only have 25 minutes. I'm going to take 30. I'm going to take it all.
Oh, no.
Yeah.
So you mean I can't ask you questions?
You can't ask me that. Maybe that's a little bit.
Oh, no.
And Maddie, you and David Artnow are going to be talking about client development and
yes.
.NET MAUI.
The .NET MAUI Power 2 Hours coming up this afternoon. I think it starts at 1 or 2 p.m. Pacific. Who knows? It's not the time zone I'm usually in, so time is irrelevant.
All right. So now coming up, though, we have the keynote, the state of the platform of ASP.NET Core with Dan Roth.
Dan, how you doing?
Hey, Maddie. I'm doing great. It's great to be here at .NET Conf 2022. Hello, everyone. I'm Daniel Roth. I'm a product manager on the ASP.NET team. And I'm thrilled to be here at .NET Conf to see all the great new features in .NET 7. In this session, we're going to look at all the new stuff in ASP.NET Core in .NET 7 for web developers. ASP.NET Core is our modern web framework for .NET. It's unified and provides everything you need to build beautiful web UI and powerful back-end services. Unlike other development platforms that require you to piece together a web app from different frameworks, ASP.NET Core gives you a complete and cohesive web development solution. If you're building web UI, you can use MVC and Razor Pages to dynamically generate UI from the server. You can integrate with popular JavaScript frameworks like Angular and React. Or you could build your entire rich interactive web UI in C# using Blazor. For backend services, you can build standards-based HTTP APIs. You can build real-time services with SignalR and powerful backend services using gRPC. For all of your cross-cutting concerns, ASP.NET Core provides a rich array of middleware that you can use for common needs like routing, security, localization, and much more. ASP.NET Core integrates with cloud-ready .NET Platform extensions that handle concerns like logging, configuration, and dependency injection. And then when you're ready to host your ASP.NET Core web application, it can run on a variety of servers, including Kestrel, our built-in, ultra-fast, cross-platform web server. So no matter what type of web app you're trying to build, ASP.NET Core has you covered so that you can stay focused on your app and stay productive. Now, ASP.NET Core delivers industry-leading performance. In the public Tech Empower benchmarks, ASP.NET Core maxes out the test hardware to deliver a whopping 7 million requests per second, which is 11 times faster than Node. With gRPC services, ASP.NET Core is faster than Java, Go, C++, and Rust. But it's not just about benchmark performance. ASP.NET Core delivers real-world performance for global-scale applications. At Microsoft, we use .NET for many of our products and services, and as they've upgraded to use the latest .NET versions and ASP.NET Core, they have realized enormous performance gains and significant efficiency improvements. For example, Microsoft Graph provides access to data and intelligence for the Microsoft 365 ecosystem. They handle 70 billion requests per day. When they upgraded from .NET Framework to .NET 6, they were able to reduce overall CPU usage by 37% and also reduce operational costs by 91% for each 1 billion requests served. Azure Active Directory, their gateway API, handles 185 billion requests per day so that you can log into all those cool services. When they upgraded to .NET 6, they reduced CPU usage by 67% and increased app efficiency, the ratio of throughput to CPU usage, by 50%. Microsoft Teams migrated 50 projects and 700 APIs, reducing CPU usage by 25%, improving P99 latency by 60%. And the list just goes on. Azure Cosmos DB, 5 times the throughput. Exchange Online, they reduced P99 latency by 80%. Azure App Service, they moved their front-end roles to .NET 6, and they were able to increase throughput by 80%. But what's really cool is they were also able to replace Nginx in their Linux worker VMs with ASP.NET Core and Kestrel, and that allowed them to unblock new scenarios and features like HTTP2 support and gRPC. So by building on .NET and ASP.NET Core, you're on a sure foundation that's built to be efficient and ready to scale. Now, we just announced the release of .NET 7, which is loaded with great new features for ASP.NET Core for web developers. ASP.NET Core in .NET 7 is built for speed. If you thought .NET 6 was fast, .NET 7 is even faster. In .NET 7, we also added support for the latest protocols, standards, and architectures so that you can be sure that you're always getting the best of the web. At the same time, we simplified web development in .NET 7 so that you can get started fast and still take advantage of all the latest and greatest features. To help you stay productive, we've added even more middleware, like support for output caching, rate limiting, request decompression. We've added new features to SignalR and Blazor, like SignalR client results and Blazor custom elements that enable new scenarios and empower you as a developer. Let's take a look at each of these. All right, so ASP.NET Core in .NET 7 is faster than ever before. It delivers next level performance with .NET 7. Thanks to optimizations across the .NET platform, ASP.NET Core now performs on the Tech Empower benchmarks, has posted significant performance gains. So 8% faster on the plain text benchmark, 16% faster with JSON handling, 25% faster with the end-to-end fortunes test. HTTP2 is way more optimized in .NET 7 than in .NET 6. For example, if you're doing gRPC server streaming, .NET 7 is 8 times faster than .NET 6, making it faster than Go. We also did work to make sure that you can take advantage of all the processing power of machines with lots and lots of cores. ASP.NET Core in .NET 7 is 5 times faster on the massive 80-core ARM64 Ampere Ultra VMs that are available on Azure. So all these performance improvements, they mean lower operational costs for you and better user experiences for your users. Now, we work hard to support the latest protocols and standards with quality implementations that are tuned for performance and also hardened for security. In .NET 7, ASP.NET Core now supports HTTP3, the latest version of the HTTP protocol. This enables faster connections and also better multiplexing over a connection using the new UDP-based quick transport. We added support for WebSockets over HTTP2, so you get that familiar full duplex programming model over an HTTP2 connection. And we added experimental support for web transport, which is a new draft protocol for multiplexing streams and datagrams over a single HTTP3 connection. All of these new protocols are available cross-platform, on cross lovely empty JSON array. So it's working, we just don't have any to-dos yet, but it's doing JSON serialization and handling all that for us with just that one line of code. That's pretty great. Okay, now we need a way to actually add to-dos to our API. We need like a post-based endpoint. Let's go ahead and add that next. We'll add a post to-dos minimal API, so map post. It'll be at the same URI. And here we're going to actually take the to-do instance in the request body, and then we'll inject the to-do database context again. We'll add the to-do to the database, save it, and then below we're returning not just a result, a typed result. This is a new feature in .NET 7. Let me zoom in here. So this API is actually returning created of to-do, a nice strongly typed object that represents the result of this API. It's new in .NET 7. That makes our API much more explicit, easier to test, and we get better OpenAPI spec generation. Now we do still have this repetition of the URLs for these APIs. That's seems a little unfortunate. Can we consolidate those somehow? And the answer is yes. We can do that in .NET 7 thanks to the new support for endpoint groups. Let's add an endpoint group here called to-dos. To create one, we'll do app.map group, and we'll call this one to-dos to match our URL prefix. We'll give it that URL prefix. And now what we can do is just take this to-dos instance and replace app here, and then remove to-dos here and here, because these minimal API URLs will now be relative to the group. OK, let's make sure we didn't break anything. We'll go ahead and run the app again, just to make sure that our GET request is still working. All right, there's hello world, and then slash to-dos. OK, great. So still working, but we still don't have any to-dos. We have a post endpoint now, but we need in my launch settings. I don't want to keep opening up Hello World. Let's go and change the launch URL to Swagger. All right, great. So now it should open up the Swagger UI for me automatically. Let's run that and see what we get. I think we can close a couple of these tabs. And there we go. OK, we got some Swagger UI. It looks a little weird. There we go. So now we can see, let me make that a little, zoom out a little bit. Oh, my goodness. Let's zoom out a little bit so that we can see the text. OK, so now we can see our get endpoint and our post endpoint. We can try it out. Let's add a to-do. Let's call this try .NET 7. And let's go ahead and execute that. And if we look below, hopefully, yes. OK, we got our, what do we have like this? Our 201 created response with our new to-do. So that looks good. So we're able to create to-dos now. And if we go up above, we should be able to get the list of to-dos from our API as well. And we can. So there's our created to-do. Great. So now we can create to-dos. We should probably add all of the other endpoints for doing like put and delete and those things. I'll just quickly add a snippet to add all those. There they all are. So we got put, we got map by get. Well, I think I'm missing a namespace. Let me Let me fix that up. Okay, we got get by ID, put, and delete is below. Now, one thing I want to call out here that's interesting, so this get by ID, it's also using type results, but it could return one of two different results. It could return a 200 OK, or it could return a 404 not found. And those are different types. How does that work? Well, new in .NET 7, we have this results type, which basically acts like a union type so that we can explicitly say, in a strongly typed way, that this API could return either of those two results. If we go ahead and run the app again and look at the generated Swagger UI documentation for our get that takes an ID, sure enough, we are seeing that it can return a 200 or a 404. So that looks beautiful, much more explicit about our API, better documentation. Now, the last thing I want to do is I want to update this API to also be secure, to have authentication and authorization. That's been a bit tricky to do in the past, but with .NET 7, it's way easier. We basically just have to add 2 lines of code. Let me go up here into our services, and I'll add the auth-related services. So I'm doing add authentication and then add JOT bearer-based authentication. So you're going to need a JOT token to only one send with every request, and then we're also going to set up the authorization. And that's all you got to do. Okay, so now we've got authentication set up. We can add these 2 lines of code. You don't have to mess around with like authentication schemes. The default authentication scheme will be assumed to be the only ones you've got, and then the necessary middleware will be added. Let's see if we. All right. Okay, so now we've got authentication set up. We can go to security for our APIs. Let's try out just sending a post request. We can say, and yes, okay, so we're getting a 401 on auth. Saves this. Okay, so now we need to actually run, send a JOT token. Let's see if this API, so that we can continue to test and develop. Security. That would normally require us to go out just sending a post set up an identity provider. And be yes, okay, so we're getting a 401 on fortunately in .NET 7, so now we need to actually send a JOT token to this API so that we can continue to test and develop. That would normally require us to go and set up an identity provider. That can be a bit onerous. Fortunately, in .NET 7, there's a new dev time tool that lets us generate dev time only JOT tokens that we can use with our app to test its various features. The tool is called User JOTs, and to use it, we can just go to the Visual Studio terminal. It's a command line tool, and let's just run here .NET user JOTs create. Okay, that's all you got to do. And this will then set up our app so that it will honor JOT tokens that are created using this tool only for development purposes. You don't use this in production. And it will give us a JOT token. We can mess around with the claims for that and all those types of things. But for now, I just want to use this to call my API. I do have one more problem, which is the Swagger UI currently doesn't recognize that these API endpoints are secure. Like, it doesn't know that I need to pass a JOT token. This is admittedly a little bit of a gap in our OpenAPI spec generation story right now in .NET 7. We'll work on making this better, but we can fix this by manually telling Swashbuckle that, hey, these APIs are actually secure. They need a JOT token. So let's go ahead and fix that. Up above, let me hide that. We'll replace this add Swagger gen call with just a little bit of config. Let's add this. And I'm not going to go through all of this in detail, but what this is doing is it's setting up a security requirement for all of our APIs. That's all it's doing. You can go look at the Swashbuckle docs to see what this does. Okay, but if we refresh now, we should see in the Swagger UI that we now have security enabled. We should get a bunch of padlocks. Yep, so now we got all these padlocks here and up above. Okay, and we can click on authorize. There's a place to provide our JOT token that we generated using the user JOTs tool. We go ahead and authorize. I should show that here in config is where we're setting up that the user JOTs JOT tokens should be honored during development. This is just in app settings.development.json. All right, and then now we should be able to create our to-dos again. So let's try it out. Add auth. Are we done with that? Come execute. And boom, yes. 201 created again. We were able to send an authorized request. So this is minimal APIs with ASP.NET Core and .NET 7. Super simple, but also super powerful. All right, let's go back to presentation. Now, we've also made a bunch of improvements in .NET 7 for building web UI with ASP.NET Core and Blazor. With Blazor, you can build your web UI completely in C# using reusable components. These components today, you probably saw the .NET Podcasts app, and they mostly focused on the back end there. Let me find it right here. The .NET Podcast app is an app completely implemented in .NET that lets you listen to .NET-related podcasts. This is the web app implementation for the .NET Podcast that calls those minimal APIs that we saw previously. And the web app is implemented using ASP.NET Core and Blazor. This client project is our Blazor WebAssembly app, and if we look in its dependencies, we can see that it's using this podcast pages project, which has all of the components that the app needs. Those are down here in this pages folder. So there's all of our Razor components for our Blazor application. Now, if we run the .NET Podcast app, let's bring that up. I've got it running locally on my machine. All right, so this is the application. The home page is a Razor page. It's being rendered from the server. But if we go to the podcast player, this is all Blazor. It's rich interactive UI. We can like search for podcasts and click on them and flag them to listen later and all that good stuff. You know, a rich interactive user interface. Now we can take these Blazor components and reuse them also for native client development with .NET MAUI and Blazor hybrid support. If we go back to the solution, up above, we also have a MAUI project, and it's also referencing, if we look in its dependencies, it's also referencing that same podcast pages project with all the Blazor components. And then in MAUI page.xaml, we can see that it's using a Blazor web view to embed those components directly in a native client app with mobile and desktop. And we've got that running here as well. Here's the .NET MAUI app running on Windows. There's a Windows desktop version of the app. It's got all the same functionality. We can click on podcasts and see them. We can subscribe and so forth. We can see that this is actually Blazor-based web UI, because if we bring up the browser DevTools and hover over it, we can see all the HTML showing up in the browser DevTools. We can do mobile as well. Here's the mobile version of the .NET Podcast app running natively on Android. So with one set of Blazor web UI components, we've got web, mobile, and desktop. That's pretty awesome. Now, in addition to these three app scenarios, you can also take your Blazor components and host them in a JavaScript-based application using the new Blazor custom element support in .NET 7. Let me show you what I mean. So let's go ahead and close .NET Podcast. I'm going to switch over to this other project, Blazor custom elements. Now, this project is it's an ASP.NET Core server, but it's hosting an Angular client-side app. Let me go ahead and get this running. The Angular app takes a little while to get up and running. So if we go look in this client app folder, we can see all the Angular isms kicking around here. So this is an Angular app. So imagine you have been developing with Angular for a while, and then now you want to start using Blazor. You want to include it at this table. What I want to do is I want to replace this Angular counter with a .NET C#-based Blazor component. All right, so how can we do that? Well, I've got a Blazor component defined already in the ASP.NET Core project. Here it is, all C# and HTML. And then I have registered this component as a custom element, like a standard HTML custom element. Just like any other tag, you normally would implement these with JavaScript, but here we're implementing it with Blazor, and I'm registering this particular HTML tag name. Okay, so now we can use this from our JavaScript app just like we would any other HTML tag. Let's go into the source for the app, find the counter page. First, let's get rid of that Angular counter. Don't need that anymore. We'll just save that, and it should just disappear. Poof, OK. And now let's add a Blazor counter right here. We'll go ahead and save that. It's just a normal HTML tag, and now we've got a Blazor counter running in our Angular application. You can add Blazor components to JavaScript-based apps too. Super cool. Now, we want to make sure that every ASP.NET developer can take advantage of the many great benefits of ASP.NET Core. So we've been doing work to make it easier to upgrade your ASP.NET apps to ASP.NET Core. Now, upgrading can be difficult. There's a lot of changes in ASP.NET Core. It really is a completely new web framework built from the ground up. And if you're still developing your old ASP.NET app, then trying to migrate can feel like a race where the finish line just keeps moving ahead. What we've done is we've introduced new tooling for Visual Studio that lets you migrate incrementally. You can add an ASP.NET Core project app in front of your old ASP.NET app. And it will then proxy requests using YARP, our reverse proxy, back to the old application. You can then move endpoints one at a time, like controllers and pages, to the new application, and then that new app handles those endpoints, and anything that isn't handled yet still falls back to the old app and continues to work. So you can continue to maintain and develop your old app while you're migrating. We're going to have a couple of really great talks tomorrow about upgrading to the latest .NET version that you should definitely check out, or you can learn more about this tooling at ak.ms/ASP.NET/upgrade. Now, there are tons of great new features in ASP.NET Core in .NET 7, way more than we have time to cover in this one session. But that's OK, because right after this session, there's going to be a series of sessions covering all of these great new web features. So we have a Blazor talk right after this one with Steve Sanderson, a minimal APIs talk, and then we'll cover all the runtime features. There are talks on Blazor Hybrid later today, and then a lot of great web development talks tomorrow. So be sure to stay tuned in to learn about all the new stuff in ASP.NET Core in .NET 7. And with that, I hope you enjoyed learning about web development with .NET 7. Try it out today. Happy coding. And with that, we'll see if there are any questions.
Oh, that was great. Every time I hear Dan Roth talk about ASP.NET Core, I just want to go out and program with it and just.
I do too. I
love it so much. So we have this great tag board behind us. Questions? If you want to have them on here, hashtag .NETConf, and we'll take it away. So let's see if we have anything. Well, first off, we have tons of watch parties going on right now. Here from Omaha.NET user group. Hello. Hello.
Hello, everybody.
And I know we have a watch party going on across the street as well today at the Reactor right now over here in Redmond. So that's super awesome as well. So, hello. All right. So what else do we have going on? Just a bunch of new ones.
All the exciting.
Yeah.
Ooh, here's one from Eric Winnington. I'll step in and
all right.
for you. When do we hear about hashtag YARP?
Sure. So, I mean, we use YARP. Actually, a lot of those .NET services that we implement at Microsoft, those are actually actively using YARP. It's one of the reasons why we built YARP, is because we needed it for our own services. So it's YARP is available. It's literally what it means. Yet another reverse proxy.
That's great. So Maddie, are you ready for our next session?
I think I'm ready. Are you ready?
I'm
Is
ready.
Steve ready?
I'm ready. I'm ready. Because you know what? It's Blazor. It's Blazor. It's what's new in Blazor. Have you used Blazor?
I mean, if you've heard about Blazor and you've heard about Maui, you know that they're like peanut butter and jelly.
Oh my goodness.
And they're best friends.
You're getting ahead of us. We're getting ahead of us. We're getting ahead. We're still in the web portion. We're still in the web portion. So yeah, Blazor you can run on the server. We can run it in the client called Blazor WebAssembly or Blazor WASM.
Ooh.
So yeah, super cool about that. And yeah, we're going to learn all about it in the next session coming up. And I know Dan Roth has talked about it as well. So
that's awesome. Yeah. All right, Steve, we will turn it over to you when you're ready, and you can take it away for what's new in Blazor 7.
All right, fantastic. Thank you very much. Enjoying the conference so far. And thank you to everyone who is tuning in at the moment. I'm really glad you've done that. I'll introduce myself. My name's Steve, and I work at Microsoft. I'm a developer or architect on the .NET team, particularly focusing on web stuff and with a bit of a special focus on Blazor, which is good because that's what we're going to talk about today. Now, if you've been watching the last few sessions, you'll already be familiar with where we are in the history of .NET at the moment. But just in case anyone is just watching this session, I want to make sure you know where we are on the timeline. So .NET does a major release every year in November. You may well know that. And so what has the Blazor team been doing for the last 12 months since the .NET 6 release? Well, we spent about half of our time working on .NET Maui. So that's the new Blazor hybrid feature that allows you to run your Blazor components within a native mobile or desktop application. And you may have just seen some of Dan showing you that. And then for the other 6 months, we worked on adding some great new features to Blazor in .NET 7, which I'll show you. Now, of course, there is going to be another .NET release next November, .NET 8, and we've started planning that already. We would really love any feedback that you've got of what things you would like to see in .NET 8. So if you can get onto the GitHub repo and give us some of your suggestions, we'll hopefully get some of those into the product next year. But this talk right now is about where we are today with .NET 7. So we've got a lot of great new features for Blazor developers in .NET 7, and most of them work across all the different Blazor hosting models. So whether you're using Blazor Server or WebAssembly or hybrid with .NET MAUI, most of these features will work in the same way across all of them. Now, there are also some WebAssembly specific features. Mostly those were implemented by the underlying .NET runtime team. So thank you to them for doing that. And I'll mention a few of those towards the end of this talk, but there is a whole talk about that tomorrow where you can get into more details about WebAssembly runtime stuff. Let's think now about some of the new Blazor features that work on all the hosting models. And I'm going to demonstrate them to you. So we're going to need a bit of a demo app to get started with. So let's just switch over to this sample application that I've put together. It doesn't use any .NET 7 features yet, but we're going to add some. And this is not meant to be a sort of surprising or clever sample. This is meant to be as mainstream and predictable as possible so that you can easily relate to it. So if I start this up in my browser, you will see that this is simply displaying a list of products, which is getting from a database. And if I click on one of these links, I get into an edit screen, and it does all the normal editing stuff. So I can make some changes to, let's say, this category. It tracks the changes there. If I try to save, it's going to do validation. And if I satisfy the validation rules, then it can tell me that the changes have been saved and I could go back. So pretty straightforward stuff. And if we look at the code in there, what we'll find is that this is a Blazor server application. Could be done with WebAssembly, but I just happen to have done it with server on this occasion. And if we look in there, here's an example of one of the pages. This is the index page, and it doesn't really do very much apart from just display this products list. And if we go into the code for that, this is a typical way of fetching data from a database and rendering it with Blazor Server. So this is using Entity Framework, which is why we've got this DB context there. And I'm to the life of this component. And what that means is whenever this component is on the screen, this DB context will keep going. And if the user navigates away, then it will get disposed and cleaned up. And apart from that, it just uses normal EF code. So we're getting our products. We're saying we don't need to do any change tracking because this is not an edit screen, so it's more efficient not to. I'm limiting it just to 50 because otherwise there'll be too many. We'll fix that in a minute. And then to display them, we simply have a for each loop to render these links for each of them. All right, so that's normal .NET 6 code. But can we make it a bit better? Instead of just displaying a list of names, can we display more information at once? And can we get around this limitation where it only just shows us 50 items? Can we show a lot more? So that brings us to the first thing I want to show you. Quick Grid. Now, this is actually marked as preview in .NET 7. That's not because it's not ready for production use. It's because we're not technically counting it as supported because we want to be able to change the API depending on feedback from the community. But if you're good with the API as it is, then you can use this like any other open source project. And the idea of it is it's not that it's intended to replace every other grid in the entire Blazor ecosystem. There are existing other ones, many of which have more functionality. But the idea with Quick Grid is to give you a standard basic set of features that will cover many common scenarios and that it will perform extremely well in all the different situations you might use it, whether it's WebAssembly, server, or with a large amount of data or whatever, should work well. So let's have a go. I'm going to go over there and change this screen so it works using Quick Grid. And what we notice, firstly, is that our code gets a lot simpler. All we have to do now is we get our products, from Entity Framework there. I'm still limiting it to 50, but we'll change that in a second. So we've got this queryable of products, and we can pass that to QuickGrid, and it's going to render them for us. Now, I haven't got any columns in this grid just yet. So when I switch back to my UI, we should see that it becomes blank because there's no columns for it to render. So let's go and add some. There's two types of built-in columns. We've got property columns like these ones, which just pick out a certain property in a strongly typed way to render, and we can pass other parameters too. And then there's template columns for more control over the rendering, and I'll show you that in a minute. But now we've got these 4 property columns. When I switch back, you'll see we've got this nice little grid. We can scroll around. We can do sorting because I set sortable to be true. So that's good. But I want to get beyond this limitation of only showing 50 items. QuickGrid has got the ability to do both pagination and virtualization so that you can work with much larger amounts of data. And to do that, we will first add an instance of this model type, pagination state, and I'm going to set it to have 10 items per page. And that will keep track of where we are in the pages. And I'm going to pass this in to the grid. So once that has access to that, it will respect the pagination rules. And then we need a bit of UI to let the user move between pages. You could write your own UI for that, but I'm going to use a built-in one, which is simply called Paginator. And once I've done that, if I go back into my browser, we should see now it's displaying those 10 items, and I can switch through these pages quite easily. That's good. But I don't want to limit it to 50 anymore. Now we've got pagination. I'm going to remove that take 50 from the end. And then when I come back and I'll reload on that, we've now got 100,000 items from our database, and we can very easily continue working with all that data. Now, it's not super easy, actually, because there's so much stuff. The user hasn't got much chance of actually finding what they're looking for. So we're going to need to add a search feature in just a minute. But before we get to that, let's fix the display slightly, because some of the styling is quite weird, especially these prices. Like, I've no idea how you're supposed to even read that. It doesn't look like a price. So I'm going to drop in a slightly updated version of this code, which uses some template columns as well to do things like custom formatting of the price, setting alignment, custom sorting rules, and I've got a link into the editor screen again. So with those updates in place, now things look a little bit better. That is the QuickGrid, which is available as preview with .NET 7. Let's move on to the next new feature, bind enhancements. Now, Blazor has always supported data binding from the very beginning, but we've added some new powerful ways of binding in additional ways to give you some more flexible options in .NET 7. And to have a scenario for that, let's imagine that we want to add a search UI to this screen right now, so you can quickly find your particular product. So we'll get started doing it until we run into a problem. We need a new feature. So the first thing we're going to need is a place to keep track of whatever it is that the user is searching for. So I'm having this string field here. And then I need to add a bit of UI to let the user type in what they want to search for. And I'm going to use a QuickGrid feature called column options, where we can type in whatever UI we want that's associated with a particular column. And what it will do with that is it will render a little icon in the column header. You can control what that is. And when the user clicks that, they'll get the UI that you chose. And inside there, I'm going to put a box that they can type their search terms into. And I'll use the normal data binding that precedes .NET 7 that's always been available. So I'm binding this text box here to the search name. I've got a few other attributes, and I'm saying I want it to update whenever there's an input event. That means every keystroke. The browser fires an input event on every keystroke or paste or anything else that changes the contents of the text box. All right, so hopefully that's enough to make some actual UI appear, even though it doesn't use any new features yet. And when I type in there, it does update that field, but it's not updating my search query. What I really need to do is somehow, every time this binding fires, I need to update the filter. But how do I do that? Prior to .NET 7, it wasn't very easy. You had to do some pretty weird tricks to react when a binding changes. But one of the cool new features in .NET 7 is something called bind after. It's very easy. It simply means every time that binding updates, we are going to call your function or your method, and you can do whatever you want in there, whether it's synchronous, asynchronous, whatever. And if you need slightly more control, we've got a more advanced version of it called bind get and bind set, which gives you ability to do custom logic both before and after on both sides of the binding if you want to do any conversions. So anyway, let's use bind after. And I'm going to say that after the binding updates, I want to update the filter. And I haven't defined that yet. So let's put in an implementation of that. And here's my implementation. It's just going to use Entity Framework APIs to add a where clause based on the search name that you've entered. I can also slightly simplify on initialize now to just call update filter. All right, so if that works, then when we come back here, every time this binding updates, you'll see it calls our update method, and then we can automatically update our query. All right, so we've got working search, and within that search, things like paging and sorting will still work. So that's nice. All right, next new feature. A pair of related features, in fact. The community has been asking for this for quite a long time. It's one of the most highly demanded features, and it's the ability to receive a notification before the user navigates and have the power to do things with it, such as cancel the navigation. So we've added this new event called location changing that tells you when the user's navigating. And in case you want to use that with an editing scenario, we've added this special flavor of it called navigation lock, which is a component that you can use if you want to help the user so that they don't lose any changes if they try to navigate away while they're in the middle of editing. So navigation lock is just a particular usage pattern for the underlying location changing event. And I'm going to show you it because otherwise it's not going to be very clear what I'm talking about. So let's go to one of these edit screens here. And I'm going to go into edit this product, and I'm going to change the name changed like that, and I'm going to maybe change the stock a little bit as well. Now imagine that as a user, I forget to save my changes. I don't remember to press this save button. I just click this link to go back to home. Well, what will happen is I just lose my changes, which is not very good. Another thing that could happen is what if I leave the site entirely? Again, I might lose my changes. So to show you, I'm going to go to an unrelated website, Microsoft.com. And then when I go back in here and I start making an edit, edited again, like that. At this point, I could use the back to go all the way back to Microsoft, and it won't do anything. It will just lose my changes. So let's see if we can stop this problem from occurring. I'm going to go into the code for this edit screen here. Now, I know there's quite a lot of code here. You won't have time to read it all. Don't worry about it. This is just the normal way to do editing with Blazor and has been for a long time. We've got this edit form. We've got a context which will keep track of the edits. We've got a thing that activates validation. And we've got various components for displaying the UI, for editing the data, and for showing validation messages. But that's not new. I want to show a new thing. So I'm going to show you the navigation lock component. And this deals with two different types of navigation: external navigation and internal. And the reason for the distinction is because the browser forces you to make this distinction. External navigations are if the user is leaving your site completely using the back button or following a link or closing the browser. And the browser will not let you stop the user from doing that, but it does let you ask them to confirm it. So that's what this is doing. It's saying if you're doing an external navigation and you've got some unsaved changes, then we'll ask the user to confirm it. So let's see if that works, shall we? I'm going to go back over here and reload. All right, and now I'm going to go and start making an edit. I'll say edited again, like that. And I'm going to try and go back to Microsoft.com again. And this time you'll see we get a little message that shows up. The browser won't let you customize this message, but it does let you ask the user to confirm it. So the user could cancel if they want to. And similarly, if they were going to close the tab, it will show you them the confirmation, or even if they were going to close the entire browser, they'll get that confirmation prompt as well. Of course, they can choose to go ahead with it if they want. Now, the other scenario is internal navigation. That's when the user just moves to a different part of your site. And in that case, there's no limitations. You can do anything you want. There, the browser won't stop you. So we've got this different callback that will occur for internal navigations, and you can put custom logic in there. It can even do async things, so you could force the user to save their changes automatically at that point, or you could just always unilaterally cancel it. It's up to you. But what I'm doing in this case, just to show you, is I'm adding a confirm prompt that's kind of similar to the other one. And if the user doesn't confirm it, we will prevent the navigation. So let's see if that works, shall we? I'll come back over here and I'll reload, and I will confirm the external navigation, because reload is an external navigation. I'll make a change. For example, I'll change this stop count, and then I'll try to click on the index link. That's an internal navigation, so it will run my custom logic and it will ask for confirmation, and I'll cancel it. And just to show you, if I do save the change first, then when I click the link this time, it's not going to show any confirmation prompt. So there you go. That's how you can use navigation lock, which builds on top of the location changing event to give you a nice pattern when you work with editing data. Let's move on. Next new feature, custom elements. Now, if you watched the previous session, you will have seen an example of this where Dan showed how you can use custom elements to host Blazor components inside an Angular application. And I'm going to show you this in a slightly different way just now. So if you don't know, if you didn't watch the previous session, what this does is it allows you to say that Blazor components will be registered as custom elements, and that lets you use them from other web technologies. So if you're doing some other client-side rendering, whether it's with something like React or Angular, Vue or Svelte or anything else like that, you can have those other technologies render Blazor components. And similarly, if you're doing server-side rendering with Rails or PHP or anything else, then again, you can get those technologies to render your Blazor components. So to show you that, and just to have a bit of a change from Angular or React, I'm going to use a server rendering technology. Let's imagine we want to integrate this products manager with a WordPress site. Now, I know WordPress is not exactly hot new stuff, but it is very mainstream. So that's why I'm going to show it to you. And obviously, it doesn't know anything about .NET, which is nice because we can show that it still works anyway. So I've got this WordPress site right here. You know it's WordPress because it tells you that. And I've got a page on it called All Products. And I want to show my Blazor products grid right here. Now, the way that you can do that is you need to host both your Blazor code and your WordPress, in this case, code on the same domain. It's not intended for cross-domain hosting scenarios. Maybe we'll add something for that in the future, but that's not the case right now. In this case, I have got my Blazor server application and my WordPress site running on the same host, so I can make them work together. And what I do is I go into whatever you use to configure your other technology, and you make it render the script tag that loads Blazor. So in this case, it's Blazor Server. It would also work with Blazor WebAssembly. In fact, it's slightly easier to do it with that. So I'm loading that into my WordPress site. I'm also adding some CSS just because I want the styling to match up. And I've got this base tag so that links will also work. And once you've done that, you can go and start using your Blazor components. So in this case, in my Blazor code, I have said I want to register a custom element, and it's going to be the products list, and I'm giving it the name products-list. And since I'm loading the Blazor script into WordPress, I can now use that in my pages here. So inside all products, this is where it says to do show products grid, and I'm going to add a products list right there. So I'll hit save on that. And then when we go back to that page, you'll see we've now got our list of products rendering inside the WordPress application. And of course, it's got all the same functionality that you'd expect. It's got sorting, it's got all the searching, and it's got pagination. And it's partially integrated the styling as well for me, because I've got both WordPress CSS and Blazor CSS loaded together here. So they're kind of working together to control the final styling. So that's nice. But one other thing we could do is pass parameters as well. Let's say we want to have a page here called batteries that just displays batteries. At the moment, it displays everything, even though it's trying to just display batteries. So let me show you how it's trying. If I go to the editor here, you can see it's trying to pass a category and a subcategory into my Blazor code. But the Blazor code doesn't know anything about these parameters, so it's just ignoring that right now. But we can make it know about those parameters, and then it will work. So I'll go into my products list component, and I can use normal Blazor parameters, for example, here I'm adding category and subcategory parameters, and then I will change my filter logic so that it respects those parameters and adds extra where clauses for them. So here we go. We'll say if you've given us a category, we'll add a where clause for that, and similarly for the subcategory. And now we've added that feature. If I go back to this page and reload it, you'll see that the batteries screen now just shows batteries and all products shows all products. So there we go. The point of that is simply that we can integrate Blazor, whether it's server or WebAssembly, with other web technologies, whether they're client-side rendered or server-side rendered, which may be very useful in many of your scenarios. Okay, so let's move on now, and we'll talk a little bit about Blazor WebAssembly and a couple of the new features that have been added there, starting with loading progress. Now, hopefully your Blazor WebAssembly app loads nice and quick, but it's always possible that some users will be on slow network connections and they might be waiting a little while for it to load. So it's kind of nice if you would show them the progress as it goes. So that is something we've now baked in by default. I'll show you the updated Blazor WebAssembly project template. So I'm just setting that as startup. I haven't changed this template in any way. This is just how it comes out of the box. And if you were very fast, you might have seen the loading indicator show up. It's a bit too fast to really see. So what I'm going to do is I'm going to go in my browser DevTools and I'm going to throttle the network to be extra slow. So it's going to load super slow, and I'm going to clear my browser cache. So it's definitely loading everything. And when I reload now, because it's throttled, it will take a while. And you can see that it's updating this progress as it goes. So the user's got a sense of how long they have to wait. Now it's styled in this circular way right now, which we thought looked nice, but of course it's designed for you to customize and change in any way that you want to. All you have to do is go to the place in your index.html where that markup exists, and you can change it. So by default, we're rendering this SVG that renders a couple of circles to display, and I'll show you how it works in terms of getting the loading progress dynamically in a second. But to do that, I want to show it to you in the context of another thing, which is the new empty template. And we've added this for both Blazor Server and WebAssembly. And the idea of this is, after you've made a few Blazor sites, you probably don't really need to see any more counters and fetch data screens. You might have had enough of those by now. Quite a few people said they wanted a more empty template, so we've added that. And I'll show you what that looks like. And it's not completely empty. It's got some of the things that you need functionally to make your application work. But when it comes up, you'll see all it actually renders is just the word hello world. And if we look at the sources in that, you'll see there's only one page in there. And inside there, it simply displays hello world. So it's a slightly nicer starting point. And we've also simplified the CSS as well. So it doesn't have Bootstrap by default. The only CSS that it's got in there is 32 lines, and it's one thing that's to do with accessibility, and all the rest of it is just to do with how the error messages are styled if you have an unhandled error. That's just because if your error messages don't show up, it's kind of difficult to do your development. So we've added some default styling for that, but everything else is there for you to sort out yourself. All right, now I want to show you how we can set some custom loading progress in the context of this empty template. So I'm going to go here in my index.html to where the loading message is displayed. And let's just check that we can see it's loading. So I'm going to, once again, make sure that my network is throttled. And I will clear the site data so that it's going to go very, very slow. And now you'll see the word loading stays on the screen for quite a while. Let's customize it, shall we? What I'm going to do is I don't want a circular progress bar this time. Just to show you we can do other things, I'm going to add a linear progress bar. And it's quite easy to do. I'm going to add a single div with this custom class called linear progress. And then I'm going to add a bit of CSS to control how that renders. So my CSS is going to look like this. I'm going to say it's got a silver background, it's got a particular height, a particular width, and that's all I'm saying about that at the moment. Also, I want to render another element next to it or inside it, which is going to be blue. And I'm going to set this to be 30% of the width of its parent. And I've got some other stuff to do with animation as well. All right, so that's not really going to show the load progress because it's hard-coded to 30%. But let's just check how it displays. When I reload, you'll see, oh, I need to clear my cache again if we want it to really be there. Okay, you'll see it's now showing that 30% value. And if we want it to show the real load in progress, we can simply use a CSS variable, which is now built in. It's called Blazor load percentage, and Blazor will automatically change that dynamically to match the current load percentage. So if I go back and clear my site data one more time and reload, then this time you'll see that that progress bar is dynamically updating to show the actual load progress. And it's very slow because of what I've done in the network tools, but it is actually working. All right, so that is the empty template and loading progress. Now there's other WebAssembly specific features too, which you can find in other talks in this conference. One of them is some enhancements to how authentication works, some new extensibility points that allow you to run some extra logic before and after auth so that you can pass some additional parameters to your authentication provider if you want to control a little bit more about how the auth works. And then there's also some big improvements to the underlying runtime in terms of its performance. So we've made AOT quite a lot faster. I don't have specific numbers, but in some of my experimental benchmarking, I've been getting apps that have been almost twice as fast with .NET 7 AOT as they were with .NET 6 AOT. Not promising it's always going to be that much of a multiple, but I'm just saying it can be quite a bit faster. And we've also got now support for vectorization, or SIMD. Now, that's a little bit advanced. That's generally used with numerical algorithms. And what it means is that even on a single thread, your CPU can process multiple streams of data simultaneously. You do have to change your algorithm to make it use these new, the SIMD APIs, but that is now supported on WebAssembly. It's been supported in regular .NET for quite a few years, but it's also now ready to go with your WebAssembly code. And then finally, quite excitingly, we have got an alpha level preview of real multi-threading for Blazor WebAssembly. This is not something that we expect you to actually use in production. In fact, it can't even be used out of the box in Blazor WebAssembly. We're going to add that shortly. But if you're using .NET on WebAssembly, there is the opportunity for you to try out .NET 8 multi-threading now, so you can get a sense of what works, what doesn't, give us some feedback. This absolutely isn't intended for production use just yet, but it gives you a sense of where we're going. And you can find out more about Blazor WebAssembly runtime features tomorrow in a talk that is all about it. Okay, so that is all we've got time for in this session. If you want to learn some more, you can go to the URLs that you see on your screen right now for an overview of all the ASP.NET Core features, including Blazor ones. And if you want this product manager sample that I've shown you just now, then you can go to the URL there and get that and try that out yourself. So there we go. That's all I've got time for, and I will hand you back. And I hope you have a great rest of the conference.
Cool. Thank you so much, Steve. Hang on for just a few seconds because we have some tweets rolling in, some questions for you. And again, if you want to ask questions throughout the show today or the rest of the week, hashtag .dotnetconf on Twitter. Matt, what do we have over here?
All right, we have one question coming in from DB. Are there any improvements to the debugger for debugging native Blazor WASM projects?
Yes, there are. I probably should have listed that. Did I list that on my slides? I did. Look, see, bottom right, improved debugger. Yes, there are some improvements. I don't have the exact list of what they are in my head, but there's a whole bunch of cases where the debugger wasn't able to evaluate properties or didn't provide quite the expected call stacks and so on in the past. And the runtime team did a bunch of great work to sort out a whole load of those scenarios. So it's much, much more capable of showing you the right and expected data as you're using the debugger now.
Great. And we have a couple, not necessarily questions, but people are super excited about the Quick Grid. David Pine here has a URL up. David's one of our content writers for .NET. If you want to see more quick grid information, asp.net.github.io/quickgridsamples. So, and there's a couple other tweets coming in about the Quick Grid as well. So that's super exciting to see that the community's super excited about the Quick Grid.
Steve, can you customize the Quick Grid to do and look like whatever you want?
Yeah, it doesn't really have very much built-in styling. It's expected that you would use CSS to control the way that almost any aspect of it appears. And in terms of the actual markup that's coming out of it, you can nearly always customize that. You can have custom column types, custom headers, custom pagination. Yeah, it's very much intended for customization.
Awesome. All right.
Great. And there's a couple other things I want to call out here. Let's see. Jeff Fritz said, well, you want to head over to the dotnetconf GitHub page, and I'll pull this up as soon as I find it, because we have a ton of like wallpapers.
Digital swag.
Digital swag, that's what it's called. Wallpapers, and even best, have you ever heard of VS Code Pets?
I have not. What is that?
All right, so it's a VS Code extension.
Okay.
You go, and of course you have to download it. You enable it,
okay.
And you have the .NET bot. It'll go across the bottom of VS Code. So you have a .NET bot pet as your pet
while I'm coding?
While you code.
That's so. Wait, can I get Clippy?
I can get. You can get a cat.
Oh, okay, cats. All right, that's almost as cool. All right, well, let's pass it over. We have Safia and Stefan here to talk about minimal APIs in ASP.NET. Safia, you might have seen in the keynote earlier this morning, or whenever that was for you. So take it away, you two.
All right. Hi, everyone. I'm Safia.
And I'm Stefan, and we're here to talk to you about how to make the most of minimal APIs in .NET 7. As a bit of an agenda, we're going to talk about the new endpoint filters, route groups, some improvements we made to auth, new concept called endpoint metadata providers, and general improvements we made to testing. So to kick things off, Safia is going to show off some endpoint filters right now.
Amazing. Cool. So I'm going to hop into my editor here. One of the things that we were tasked with, Stefan, was building a training API for a local gym. Now, this API is pretty simple. We want to be able to manage personal trainers who work at the gym and clients who attend the gym. So we've been working hard on this API. We've got all of the endpoints associated with our application here. You can see all of the client-related routes up here, and we've got all the trainer-related routes down at the bottom. Now, one of the things I was tasked with was adding support for logging in our application. And I want to take advantage of a new feature in .NET 7 to add the support, specifically endpoint filters. Endpoint filters allow you to introspect the parameters that are sent to a particular request, process them as you might see fit, modify them, and also intercept the responses that are emitted from a particular endpoint. In this particular scenario, I've implemented this request auditor endpoint filter. It's a pretty basic filter. It's going to take a look at the current path that is being requested and simply log it to my logger. One of the things we'll notice is that these endpoint filter factories have access to application services. So we can access things that are in DI. Here, I'm accessing the logger factory to support logging in my filter. We'll also notice that they have access to this endpoint invocation concept. This allows me to access the parameters that are being sent to my requests, as well as the HTTP context. Here, I'm using that to get the request and the path associated with my application. So what I expect to happen here is that every time a user hits an endpoint in my application that has the filter registered, this logic will execute. But how do I register this filter? Great point. We're going to scroll up to one of our endpoints here. We've got our client's ID endpoint with this get method. And you'll notice that I'm invoking the add endpoint filter factory method to register the request auditor factory that I just showed you. So let's go ahead and see this in action. I'm going to go ahead and run my application. And we're going to observe two things happening. First, we've hit a breakpoint in the factory associated with our filters. Filter factories are functions that return filter delegates. Here we can see that the factory is invoked once when we start our application. We're using it in this case to access the DI container and get the logger factory. If I hit continue, we'll notice that it's invoked every time a filter is registered in our endpoints. That's an interesting point to capture, and it's going to touch on something we're going to show you in just a bit. For now, I'll continue through. Once our application has launched, we can go ahead and test our actual filter. We'll do that by issuing a call to the client's ID endpoint. So we'll try it out, pass an ID, 1 for example, and hit execute. We've jumped back into our editor because our filter has been invoked now. And we'll notice that we're able to inspect the path that the request was sent to. Here you can see that it's being sent to the client's 1 path. That's the ID that was just emitted. So this is going to go ahead and log that message out in my console. So we're going to go ahead and continue. One thing I'm noticing, Stefan, is that I want this request auditor filter applied on a bunch of the endpoints in our application. So I want it on all the trainer routes, I want it on all the client-based routes, but I'm finding that I keep having to call add endpoint filter factory on every endpoint, and it's getting a little tedious. Do you have something that could help me with that?
All right, yeah, I think we do. And this is going to bring us to a new feature in .NET 7 called route groups. One of the feedback, or a piece of feedback that we got in .NET 6 regarding minimal APIs is that there's a lot of repetition. In some cases, when you say need to add a filter to a bunch of endpoints or add, say, something like an attribute. With MVC controllers, you can add an attribute to an entire class, and that can keep your code more dry, right? So you're not repeating yourself. So if we take a quick look at this new version of Program CS, you'll see that we have this method that we're calling called map group. And this map group method returns what's known as a route group builder. So it's taking a route pattern. One thing you'll notice here really quickly is that we're not just taking a prefix that's static. We're taking a route value. That's the ID. This can be done in a group. You can even apply a group to your entire app with like an empty string that's allowed. So a route group builder is something that allows you to both call methods like mapGet, mapPost, and mapController if you want to. So any number of ways to add endpoints, map Blazor pages. And it also implements this maybe lesser known interface called the iEndpoint Convention Builder, which then allows you to do things like add filters to a bunch of endpoints at once. So in this case, I took your example with the request auditor, and I'm applying it to every endpoint that's for clients. So if we try it out, right, you see that here we just pass in an empty pattern. For what it's worth, that's equivalent to doing this as well. We kind of, when we're merging groups, we always separate with a request auditor. And let's see how it goes. A new feature in .NET 7 here is super excited to get your feedback on. Take this return value, this route group. One adding missing feature from this endpoints not to add, but to clients. So, which is, for instance, if you want to call something like client's ID and then in this case authorization, and you still have to call that. Let's take a real quick look. So if we look at the Swagger output, we'll refresh and we can make not just a group quest. The idea there is that you can use the metadata, right? And so if you have middleware that is so-called endpoint aware, like authorization, if we look at our console output, you can look at the metadata added to the group. This is a new feature in .NET 7. We're super excited to get your feedback on. One notably missing feature from this is you can it's something we've considered. So we'd love your feedback. For instance, if you want to call something now, I teased authorization a little. We didn't go into that super heavily, but that's another thing that on the entire app.
I was actually just hoping to share some things about that.
The idea there is that you can use the metadata, right?
that will be assumed as the default. So we save you a little bit of typing. If it's only one, it's assumed as the default. We've also made some improvements to the process for constructing authorization policies. There's a new extension method on services called Add Authorization Builder. When you invoke this method, not only will authorization services be registered in DI, you'll also get an authorization builder that you can construct policies on directly. So I'm using that here to construct the trainer access policy that we're going to use to lock down our trainer-related endpoints to admins. So that's step one. We've defined our authentication and our authorization policies. Now, I want to make the experience for testing authorization locally a little bit simpler. And I want to do that by leveraging some of the authentication integrations that exist in OpenAPI. Now, if you notice, if we head over to our OpenAPI page, we've got this lock icon in the top right corner, and we've got endpoints with lock icons on each route. So how did we get that working? Let's take a look. First, the fact that we were able to infer that authorization is enabled globally for our application is because of support for the new Infer Security Schemes option in Swashbuckled's generator options. So I've set it here to true. What will happen is if we detect that there's a job bearer authentication option in our application, we'll automatically generate the OpenAPI metadata required to show that authorization button in our UI. Now, that just configures authentication globally in the application. It says, hey, there's endpoints here that need auth. But it doesn't configure the fact that individual endpoints need to be lit up with auth. To do that, I've implemented an extension method called Enable OpenAPI Authentication that leverages the new with OpenAPI extension method that we released in .NET 7 to add the security scheme definition for individual endpoints that require authorization. So with those three steps and a little bit of magic inference, we're able to get the authorization working in all the places I need it. Now at that point, what I want to be able to do is present tokens to the authorization provider. How do I do that? We teased this a little bit earlier in the keynote, but we want to leverage the new .NET UserJots tool to generate tokens locally for testing. Now, what's great about the .NET UserJots tool is it supports a ton of different customizations. Based on what kinds of claims, scopes, and roles your application is configured to accept, you can create tokens that either match those requirements or don't match them if you want to test how resilient your application is to invalid tokens. So what I've done here is I've generated a token that matches the policy that is expected by my application. My policy, as a reminder, expects us to have a role trainer and a claim that says we have admin permissions on the application. And I get a token that's generated with this particular information. Now here we go. I can copy the token over into my Swagger UI and be able to test some of the endpoints in my application that require authorization, such as the get trainers endpoint. So let's try this out. We'll hit execute. We hit our logger endpoint. Trusty, good to know that we're doing the right things. And one of the things we'll notice is that the authorization token has been passed in as part of the header to the request. And our authorization middleware is able to validate that token and assert that the claims and scopes and roles that are configured on it are correct or incorrect. In this case, we provided a valid token. So we get a 200 response with an XML response body. That's interesting. We kind of talked about XML results at last year's .NET Conf. Looks like we were able to do it here. Stefan, do you want to share how we were able to get that working?
Yeah, so last year when we were moonlighting for Contoso Construction, we created an XML result, but it didn't give us that nice Swagger output that actually told you it would be XML. So you could, using groups, let's say that like all these trainer endpoints were XML, they're not, but let's say they were. You could do like produces response, or with various, don't have the IntelliSense, but you can add response type metadata to an entire group manually. But if we take a real quick look at this get trainers service, we'll see that we're returning this XML result type that we created last year in .NET Conf. But with a new addition. So we're using the extension method syntax to make it super easy. We, like we showed last year. Watch. I unfortunately can't rehash it all, but who knows? Maybe if we have time and questions. But this is basically for just a quick refresh, implementing iResult. So those of you who are familiar with MVC, this is very similar to action result. You can basically party on an HTTP context and write whatever you want directly to HTTP context response.body. And that's what we do right here with the XML serializer. What's new in .NET 7 is this endpoint metadata provider. This is taking advantage of a new C# feature, which are static abstract interfaces. I think they're super cool. When I first heard it, it's like, how can it be both static and abstract? And what it really comes down to is basically when you're using something like generics, or when you know the type at build time, you can basically call these static methods to infer, in this case, additional metadata about the endpoint. So what we're going to say when we call this static populate metadata method is that we have XML response type metadata, which will, 200 status code, sets application XML response type. And then in minimal APIs, we will discover any return value or parameter value that implements endpoint metadata provider. Or there's also for parameters. So if we take a quick look again, we were just looking at this. This is providing you with the method info. So this is the reflection API that can give you all the parameters to your route handler, as we call it, right? So that in this case would be this get trainers method is our route handler, and this is returning our XML result. This is not really the main point of this talk, but this is using a new results kind of union type. Nice. And this is important because we could change this service and it would be valid to be like, we return an iResult. And this will work at runtime, but then we're going to lose all that Swagger metadata because our analysis is based on minimal APIs being able to observe that, hey, we can return an XML result, which we know is application XML based on that produces metadata, or not found, right, which is a 404. Additionally, if you're using like a parameter, if we take a quick look at XML result, there is one other similar type. It's endpoint parameter metadata provider. So if you're like implementing try, parse, or bind async, we're not going to go over that again, though those are now also static abstract interface methods if you want them to be. You can get the parameter info. So you can specifically say the name of your parameter. If that's important to like how you're binding, you can take advantage of that. And then you can populate the metadata. So let's get this back to building. I actually do have it running already in the background from before. Nice. So let's see. Let's go. I'm going to have to, hopefully I didn't copy anything, using the user jots tool, which is super convenient for testing. We got to authorize this endpoint because you remember that we used the group to basically require authorization for every single thing, right? And this basically allows us to avoid repeating this a bunch of times. So now that we have that set up, hopefully, it will show us that it expects XML, like Safia, wait, not the post, the get. We didn't do all of them. It expects the XML.
Nice.
And then now that we have the auth set up, hopefully we don't get a 401. And we do
that looks right. Awesome.
Yeah. So super exciting. And just like an FYI, before we hand off to talk about some super cool testing improvements, like this is the equivalent to doing new authorized attribute. Okay, I just tried this earlier. All right, this is what I get for doing any kind of live coding. Trainer access, right? So this is equivalent. This is basically adding an authorized attribute to the entire group, but we have the convenience method for you. But anyway, I've now written all this stuff. I tested it manually using user jots and stuff with Swagger. But I mean, I'm a good software developer. So I mean, automated testing is a must, right?
Yes. I appreciate that you're a great software developer, Stefan.
I try to be.
And I agree, automated testing is a must. So let's hop into my editor here, and I'll show you a little bit of what we've done for .NET 7 to improve testing. Now, this is also a callback to our .NET 6 minimal APIs talk, where we showcased that unit testing minimal API-based applications could get a little rough sometimes because you did not have access to the results types that your application could return. So for example, if your application returned a created result or a no content result, there was no way to assert on that because the types were not public. That was something that we improved in .NET 7.
Good feedback from the community, too.
Yes, that was based on community feedback. And it was something that we improved in .NET 7, so we're always looking to iterate and refine the experience for working with minimal APIs. So what can you do now that you couldn't do before? Well, here's an example. I've got a training service which encapsulates the business logic associated with my application. I'm invoking it here with a mocked database context. I'm going to go ahead and send a request to the create client handler. This is the handler that gets invoked when the user sends a post to the client's route. Now, one of the things you'll notice is I'm actually able to do an assert.isType invocation using my unit testing library to confirm that the result that I get out of my API is the created type. Now my typed result here is cast appropriately, and I can inspect the status code to make sure that it's correct, which is, a 201 status code. And I can also examine the value that's returned as part of that result, which is the client that was created, which I've provided as part of my data here. So we can run this test, and it will work. We have access to all of the types that are needed to provide these assertions.
Confident.
Yes, it went green. I love seeing green. It's one of the most satisfying things. One of the other approaches that still works in .NET 7 is integration testing using the Web Application Factory. So I've showcased this strategy here for the get clients endpoint. You can see here that I'm able to instantiate a new API application. This is just an instance of a implementation.
Questions?
It's all sides up.
All right, so thanks, sorry. So super excited.
We've been told to riff, which is great. So how can you engage with some of the stuff that we just shared here today? There is a link up behind us that Stefan made, which is where you can see the code for this demo. I know there's a lot of code that gets shown in these talks, so go and check out aka.ms/ASP.NET/minappy demo 2022, and you'll find the code that we were just perusing through.
To be clear, I just created the shortened link. Safia created the repo.
Yes. And if you want to learn more about minimal APIs, you can check out the learn.microsoft.com page on minimal.
Oh, that was great. Thank you for riffing. Now, that is exactly how you know when it's live, because sometimes you just have to riff, and you both did great. I love minimal APIs. .NET 6, now even better in .NET 7, and I'll admit, every single API, right, is minimal API, and now with .NET 7, they're going to be even better. Now, hold on. We have a couple questions coming in from Twitter, and I just have to make sure I can find them. And, all right, right here. Is it better to have an endpoint filter apply to all endpoints or to use middleware?
So I would say that endpoint filters are super cool because they give you access to the parsed parameters and allow you basically a higher level programming model than middleware. When you're writing middleware, you're dealing with the basics of HTTP, like request bodies, response bodies, whereas with filters, you're dealing with parameters and results, which can be super convenient. If you want to customize parameters coming in based on what group it's in and so forth, that would be very difficult with middleware. So I think they serve different purposes.
Yeah. And to that end, I would add that in some ways we tried to design filters and middleware so that they share a lot of the core patterns. So for example, middlewares and filters are executed in the same order. in the request pipeline. So it's kind of this Russian doll inside-out execution model. So some of that kind of parity in the implementation makes the ergonomics similar between the two, but filters do give you a better API for accessing arguments via a getArguments invocation that you can call on the context. And there's also some performance improvements that we've made under the hood to make accessing those arguments a little bit more performant.
Super fast.
Super fast.
We kind of glossed over that these work on MVC actions. So if you want to add endpoint filter after like map controllers, that is a thing that you can do or apply it to a group.
Great. Love the fact that it's super fast. I never heard anything described as Russian dolls before when we're talking about APIs, but it actually is. That's a great way to think about it. So I did want to call out a couple more things. I talked about the digital swag before, and we already have it on an Apple Watch. Can you believe it? That's so cool. Ray Garza put it on an Apple Watch. And because I didn't have it, here it is. aka.ms, and it's actually /dig-swag. Dig, swag, that's how you're going to get to it. It's going to be a short link, going to bring you over to the GitHub repo, and you can download all the digital swag that we were talking about before. Wallpapers, the VS Pet, which is a little .NET bot running around, super great. Everything that you could possibly want for there. Now, just a quick reminder that right now we are in the web portion of our programming. So we had the state of the web with Dan Roth, and now we're going through a bunch of different web sessions where we're diving a little bit deeper down into it.
Matt.
Uh-oh, Maddie!
Oh my goodness.
Oh my gosh!
I just came in from the studio, from the wonderful DevRel Studios that are putting on this great event, and they wanted me to call out some amazing reminders about .NET Conf today, because there's a ton of things going on.
Yes.
I know you mentioned earlier there is the
and one called Music Store Entities. You'll see those in my web config here. Here they are. And all I've got to do is click on each of these, and I'm going to say, let's connect this. We'll connect it to an Azure SQL. Make sure I got the right one of these things. That was the default connection. That's my users. So I'll select users. Leave the connection string exactly the same. I need to give it the credentials for my database in the cloud. And I'll say, nope, I don't need any of this. Now click Finish. What that's going to do is that's going to put my connection string in the environment in my app service. I'll do this again. And this time, always double check which database I'm on. I'm on the entities. That's the main music store. I'll select the same thing. I'll put my credentials in. If I went to my app service, you would see that this action, all it's doing is putting these connection strings in the app service, pointing them at the actual Azure SQL instance. I can click Finish. Done. So that's that easily. I was able to take my application, make the connection strings point only if I'm running in the cloud to the version in the cloud, and now I can actually just click Publish, and my .NET Framework 4.8 application is going up to the cloud right now. So I do want to make it very clear. You don't have to get your app running on the newest .NET. It works great on any .NET to the cloud. So while we're waiting on that to get published, let's go switch. And I want to show you, it'll take this a second because it's going to go create those databases on the fly using migrations. While we're waiting on that, I want to show you some features that I ran into recently that I sometimes forget about all the cool tech we built. How easy is it to build? And Safia showed a little bit of this earlier today, but I want to drill in a little bit more. I've got a .NET 7 application here, and I'm going to call it Hunter API, and I'm just going to go and add a new folder. So let's go add a folder. We'll call this Models. I'm going to build an API and get it hosted in Azure Container Apps as fast as possible. So let's go and do an add. And I'll add a new item. And I'm going to add a class, and we'll call it person. And my person's going to have an ID. It's going to have a first name. It's going to have a last name. And it's going to have a title. Great. So I've got my class. Now I need to build it and wrap an API around that while we're doing that. And so let's do this. Let's go into the scaffolder. So let's save this. And what I'm going to do is I'm going to say I want to add a scaffolded item. So we'll go back to add. And we will say add new scaffolded item. Safia showed this morning. It is the API with read-write endpoints using Entity Framework. I'm going to click add on that. And I will warn people, I'm actually on a pre-release build of Visual Studio today. I was not going to upgrade to the new build this morning and risk stuff not working. So it's going to ask me for an endpoint class. We'll add the endpoint class. It's going to ask me for a context. I'm going to add the context. We want to use OpenAPI and type results. So what's going to happen now is it's going to go add some NuGet packages. It's going to scaffold my API. And I'll warn you right now, once that's done, it's going to cause some errors in this version of Visual Studio. This is fixed. It doesn't happen in the GA build. It's because I'm in a mixed place between working and non-working. But let's let this thing finish generating the code. And then what I'll do is I'll just nuke VS, and we'll close that out real quick. And I'll restart VS, and that'll make this particular error go away. Let's go back. Let's find the Hunter API. As I said, this is because I'm running crazy pre-release builds of the product. So what I've got here is, and IntelliSense is catching up here, it'll take a second, but it generated me this new person endpoints.cs. And inside of here, you can see I've got my map gets for my person, all these things. This is my full API written for me. I didn't write any of that code. Pretty cool. It even took my program.cs and it added a reference to this at the bottom of the app. So as I scaffold these things and it builds my code for me, it automatically puts the endpoint in for me. So if I run the application, I would actually get this. Now let's do something here real quick. We're going to go into data, we'll go into the context, and what I'm going to do is I want to put some seed data in here. So let's just grab this code right here, and we'll put this in here. I'll press save. And what this means is when it creates my database, it's going to go put a bunch of Scots in. We need some Hunter, Guthrie, and some Handsome in here. So we'll put that in. And let's go run the app. And if I do, I think bad things are going to happen. So let's try getting some people. Let's try it out. And I'm going to guess, wow, lots of exceptions there. So now why did that happen? That happened because, well, I have not created a database. And so we have this really cool feature called Connected Services. And if I click over here, notice it saw that I have a database. It's connected me to a local database. All I've got to do is come over here and say, add a migration. And actually, before I do that, let me make sure I cancel that out. In the newer version of Visual Studio, we run your app in that in terminal, but that app was still running, and so I can't add a migration while the app is running. So it'll give a second here. And so remember, I just created that class, I scaffolded, and now it's going to automatically crash for me because that's what it wants to do. Dun, 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 dun. Let's find out why it did that. Oh, I know exactly what that is wrong with. So that's my bad. So I must have messed up my model. But look at that. I made the first name and the last name strings, ints. So let's fix these. It's only real. Now, because I did that, that means I have bigger problems with this application. So let's go nuke the endpoint class. Let's go nuke the, let's go into program CS. Let's nuke the map. I'm going to re-scaffold that because the way I scaffolded that was not good. I scaffolded the wrong class. So let's go nuke the API context here as well. Make sure I don't have anything here that's API context. We'll kill that. And the rest of this should be fine. I'm going to run myself out of time with that error. So what we're going to do is I'm going to cheat. I'm going to start over. So let's go super fast this time. Hunter API 2. So we didn't like the first one. That all looks good. We'll keep that like it is. This is going to cause some fun challenges. You're going to see some more behind the scenes secrets here. So because I'm on a pre-release build, this application is not actually healthy. So let's go fix it. I'm going to swap a package out here. There we go. We'll do a build. There we go. Let's go add this back. How fast can I go? Let's go add the class again. There's the person. Let's not screw the person up this time. Prop int ID. Prop string first name. Prop string last name. And we'll do prop. It knows what I'm doing here, so there's a title. So there we go. We have our first name, our last name, our title. Let's make sure we're good to go. We're good to go. So let's scaffold again. Now we have the classes and stuff all the right way, getting some warnings about nullable. We'll do scaffolded item, do endpoints using a framework. We do person. We're going to add the new endpoint there. We'll add the context there, open API, add. We will then blow up Visual Studio one final time. And then I'll launch and relaunch, and we'll be good to go. I said you won't see this because you're running the production version, not the crazy mid version I'm running from last weekend. There we go. Let's open Hunter API 2. Now what I was going to miss last time is if I, now we got our code created again. Let's go back to data. I want to go add that sample data that I had. There it is. How fast can I go? We can get this thing to the cloud in the next 3 minutes. I know I can. So there we go. I've got my seed data here. And now, if I ran the app, it would fail. But I go again to connected services. I've got a database here. It's connected. Now I can right-click here and I can say Add a Migration. And this might be new to you, knowing we have these tools. You just click in the tool, we find your database, we bring it right up here. I click Finish. It's going to go make the migration. It's going to have all the code to create my database, create the code inside my database. Good to go. Now I'm going to go and say Update Database. That's going to go take that migration, run it against my actual application. I'm going to eat into 1 minute of my QA time here, so sorry, folks. Database upgrade with migrations. Now that means if I run the application, I've now got a fully running API. It'll return data. Good to go. Try it out. Execute. There we go. There's my people. You see that working. So we've got a fully working application here. Now, as we talked about in the keynote, we want to run this as a container, but I don't have Docker installed. I have none of that stuff. What do I have to do? This is just temporary as well. As we get closer to some of the earlier previews coming out, we're going to make this tooling a little better. You can jump out of here. Hunter API 2. There we go. Let's go enter Hunter API. And I'm just going to add this one package. This is the package that lets .NET build containers. Boom. So I'm good to go. And what else I can do, what I can also do as well is let's go in and let's create a Git repository. I want this to have CI/CD, all that kind of good stuff. Hunter API 2, private repository looks good. So there we go. So now we have our app in Git. I've got my databases. I've got all this stuff ready to go. I've added my package for container publish. Let's go right-click. We'll do a publish. I'm going to select Azure. Click Next. Now I've got App Service Linux that shows up because it knows that I'm a Linux application. Normally we would require adding Docker support, adding a Docker desktop. I don't have to do any of that stuff. It's going to go out there and query the cloud. There it is. There's my instance in the cloud. It needs a registry. I made one of those. That's what containers need. Now notice I have this option. This is the new options, SDK or Docker desktop. I'm going to choose SDK. And then I can also decide just to do a publish, or because I'm actually in GitHub, I can actually do actions. We'll actually build our container in the cloud using the SDK to do that. I'm just going to do this to go as fast as possible. I'll click publish, and the app's going to go up into the cloud with no Docker on the machine, whatnot. I've only stolen 1 minute of QA time. And so I will hand it over to you folks for questions.
Great.
Cool.
Great, thanks so much, Scott. The cloud, everything new. And what I like really about it the best is connected services. Now, it's not what I like about the best, though, Maddie. It's actually kind of brand new to me. Brand new as in like just maybe a couple years old, but it's so useful.
Cool.
Yeah, have you used connected services yet?
A little bit, here and there.
But I find them just incredibly useful. They scaffold everything out in Azure for you. It keeps track of everything for you, create some ARM templates. Awesome.
That's awesome. That's really cool.
Yep.
So, I mean, we're in cloud time now. We have another 3 cloud-related talks. Don't forget, though, of course, while you're watching all these sessions, to go to dotnetconf.net, get your digital swag, get your stuff. I don't know, get your free code mag subscription.
Indeed. And actually, first, thank you, Scott, for the talk. We loved it. But you know what, Maddie? I want to tell you something. You know how we are going to have the code party afterwards?
Yeah.
It's not a code party.
Oh my goodness, what?
It's going to be an escape room, a virtual escape room.
What?
I don't even know how that's going to work.
That's pretty cool.
Yeah.
But it's still the same link. It's on Twitch. You can use the chat and come. And Jeff will be there. Sarah will be there. Dee Dee. I think a whole bunch of people.
Yeah, it's going to be
escaping a virtual room.
Virtual escape room.
Whoa.
Yeah. I don't know.
I don't know.
Yep.
Well, Matt, our next speaker is not at the desk. What on earth is going on here?
I don't know. That person is a slacker.
Uh-oh.
Yeah. Uh-oh. You know what? It's me.
Total
slacker.
great.
All right. You know what? I'm going to take over. I'm going to go along. So I'm just going to start it up. That cool?
Have fun.
All right.
I'll see you
All
later.
right. Here we go.
Bye.
All right. So we are going to start a whirlwind tour of building .NET apps in Azure. It's going to be crazy time. We're going to go long. We're going to talk about stuff that you may already know with app services and SQL Server, and then we're going to transition over into stuff like, as Scott was talking about before, Azure Container Apps. We're going to talk about managed identity. We're going to talk about app configuration. We're going to talk about container registry. We're going to go all over the place. So let's get started with this. All right, so here we go. The whirlwind tour of building .NET apps with Azure. My name is Matt Sokup. I'm a principal cloud advocate here at Microsoft. So let's start talking about what we're going to talk about. We're going to talk first about building the app with some familiar services, as I mentioned before. We're going to do app service, Azure SQL, blob storage, actually put our images in there, and then put a CDN around it. And what a CDN does is that puts our images out at the edge of Azure so they're served very quickly to our clients. And then the whirlwind gets started. And what that whirlwind's going to do, we're going to use managed identity. We're going to put in Azure functions. We're going to put in Azure SignalR. We're going to get in app config, key vault, container registry, and then container apps. So it's going to be a whirlwind. We're just going to be going super fast. All right, so let's take a quick peek of what we are going to build so you have an idea. All right, we're going to have a couple of microservices, and what I'm going to do is just warm them up right here to make sure they are running, and then I am going to open up the app that we're going to build. And as soon as that warms up and brings up, you're going to see what we're going to have is a pizza shop. And it's going to be just a plain old pizza shop, nothing special going on. It's just a Blazor server app with the file new scaffold out, but it's calling out to two microservices. And the first one displays a menu. So it displays a menu, brings back an image of a pizza, and then we can add that pizza to an order, which calls a cart microservice. All right, so what I'm doing is I'm really keeping the .NET code itself super duper simple. This way we can see what code we do add to talk to Azure and do Azure specific stuff. We can just call that out. And so keeping the website kind of out of our Azure. But in real life, we know we would mix them all together. So here I have my pizza, and I hit place order. And now I can see where's my order. Because you know what, I'm not patient. And I want to see, hey, I want to make sure the pizza shop has my order. And I want to see if it's baking or whatnot. So what I can do here is I'm going to make this over on one side, and then I'm going to take an OpenAPI Azure function, and I can actually go through, try it out, and then see the status automatically update, execute it, and you can see, hey, the kitchen has my order. Status 2, order's being prepped, and we can go 3, it's in the oven, and 4, it is on its way. So SignalR coming over. So we have a bunch of different options going on here. So that we have on our whole PizzaConf application. So fairly simple, but we're building it with a lot of Azure services on the back end. So let's take a peek here what we're talking about again. First off, we're starting up with app service, database, blob storage, CDN, and then we're going to get crazy and talk about pretty much Azure functions, SignalR, Key Vault, and app config, and also then container registry and then container apps. So our very first one is super duper simple. We have those 3 microservices sitting over in app services. Blazor server for our web UI, and then we have 2 web APIs, which are minimal APIs. One is serving for the checkout, The other one is hitting over on the menu. They both hit an Azure SQL database. Now, what's cool about this SQL database is that it's serverless, which means it spins all the way down to 0 if it's not being used at all. So that's actually really neat in that it saves you a lot of money if you're not using it. And then over on the right-hand side is that we have a blob storage. So massive blob storage, massive image storage, not a ton of money there where you can put just a bunch of images in there. And then we're serving it with a CDN. So that CDN, Content Delivery Network, puts all our images out at the edge of Azure. So now anytime one of our clients needs to get an image, all they really have to do is hit the Azure edge, and then the Azure edge, either our images are going to be cached, or we're going to be able to communicate on the Azure backbone. Super duper fast, faster than your fiber at home. Super duper fast to go hit our image storage, our blob storage. So actually, I want to show you that because that comes for free, essentially. Not free, but for free when we're setting up in a .NET sense. All right, so I have over here, let me make this so you can see it just a tad bit better, scroll it up, and then all the way down, I have a storage account. And in that storage account, of course, I am going to have over here a blob service. And then I can see I have pizza images in it. And I have my various images. So I open up pizza 1, and then I can edit it, and there's the image itself. If I go to Overview, copy it, and you can see the URL for it as well. So it's blob pizzaconf.blob.core windows.net. But what's nice about this, what's super nice, is when I go back to my PizzaConf storage account, I can actually, in front of it, put in, if I type in just CDN, and this is neat, this is still within the storage account, I can open up an Azure CDN and put that in front of everything. So I already have it created, and it's, once I do it, it's just pizzaconf.azureedge.net, and then my CDN is right in front of it, and all I have to do is change what my URLs are. And if I open up lots of matzah, and then do open image in new tab, you can see it's now pizzaconf.azure.net, and it has the same pizza images because it's in the pizza images container, and it just serves. So I'm just changing the URL, and so there I go. Super fast, super easy to get things served out of a CDN rather than having to come directly from blob storage. Out on the edge makes it faster without having to do any .NET code. So you tuned in to .NET Conf to learn how to do something without .NET code. All right. So also I want to show off the website real quick what we're doing. There's nothing fancy here, just a couple APIs and a Blazor server website. And it's all, the web APIs itself, all we have here are adding an entity framework into it, and then we have a bunch of map gets for it, and map delete for the cart, getting things in and out. And in the Blazor server itself, I have a couple of services which call it to the web clients, HTTP clients. You can see we're just getting the cart out here. And over in the program, what I'm opening up is just doing a builder.configuration to get the menu URL out so I know which the menu service to call. So there's nothing super, this is pretty straightforward what we're doing. And so once I do it, deploy it up to Azure App Services in a Docker file. So I'm using Docker, my app service is Linux-based, and the reason why I'm calling out that I'm doing it in Docker because this is going to become important down the line. So, but it's Docker, runs on my machine, kind of takes care of that. All right, so that's what we have. Now, let's start adding, see how we can add the real-time order tracking to it. Because now we're going to make the app a little bit more cloud native. And so when we start talking about what is cloud native, you ask 3 people, you're going to get 10 different answers. But my first answer to what cloud native is that you're designing for putting your applications in the cloud, and you have to take the cloud peculiarities into account when you do that. So you're going to want to make sure that you're scalable, you're going to want to make sure that you're robust, and you have other things that you can take advantage of that are out there in the cloud that you might not have otherwise. Now, Azure SignalR is in Blazor Server, but there's also an Azure portion of it too that we can build upon. So that's what we're going to do for our real-time order tracking, is that we're going to put Azure SignalR to facilitate the real-time messaging between connected clients. To do that, I'm going to build an Azure function. Now, the function is going to kind of serve as what I'm going to call the broker. So the clients are going to be able to register with this broker to let SignalR know, hey, I'm listening, you can send me messages. And then the function's actually going to take and send that message itself. So it's going to be kind of like this broker sitting in the middle. And then the pizza web, the Blazor server app, is going to serve as our client to receive these messages. And this is what our diagram now looks like. And I'm going to open up the laser pointer and show off what we have. Here's our broker, Azure SignalR, external client, and this new line with the star in it shows the real-time messaging going on the Blazor pizza server. So I'm pretty proud of my PowerPoint skills with all the dotted lines and the stars and everything. And this is what we have going on. All right, so let's actually see this in action. All right, so I'm going to jump back out to my Visual Studio, and then I'm going to open up a different branch for it, where all the code is sitting for my Azure function. And you can see I have the Azure function added here where it wasn't before. And what's neat about this is what Azure functions are is, in a nutshell, really quick, is that they respond to external events that happen. So whether that's an HTTP event hitting it, or whether something gets added to an Azure queue or a Cosmos DB, something happens and then the Azure function gets kicked off. They're also serverless, so they can scale down to 0. However, what's nice about it, though, is once it gets kicked off, you get a strongly typed variable of what happened. So in this case, you get the HTTP trigger. So I'm saying, all right, this particular function gets kicked off on a web request. I get the full HTTP request coming in. And because I'm making it for SignalR, I added SignalR NuGet package, and then I just add this attribute to my function. Now, Azure Functions then takes care of all the hard work, the plumbing, of hooking me up to SignalR, of newing up the SignalR connection info object for me, and all I have to do is return it. So this is really the token of telling me how to connect to everything. And all I have to do is supply the connection string to SignalR, and then tell it the hub name of what I want to do. And then this is how I actually return things. And it, again, is HTTP trigger. And then way over here, and this is even pretty cool, even nicer with Azure Functions, I can do routes, just like you would do in ASP.NET. Again, getting the HTTP request, and then strongly typed input parameters. In this case, order ID and status. And then all I do need to do to return it, because I have these bindings, is say, all right, I'm going to put everything into a IAsync collector, which happens to be SignalR messages, and then just put my data into it and just add async to it. So SignalR, or Azure Functions, takes care of all that plumbing for me. Now, one more thing that I do want to call out. It's that all these open API attributes. A good friend of mine, Justin Yu on my team, added the Open API Azure Functions extension at build either last year or the year before. Regardless, what this does, it creates all the Open API spec for us, and also the Azure, or the Swagger tooling. So we can get in and actually test out our Azure Functions, at least the HTTP triggered ones, from a Swagger tool set. Awesome, super cool stuff. And again, another NuGet package, and then you just have to decorate things with the Open API parameter. All right, so then to consume the SignalR, I have that down in my pizzaconf.web, and it's in the tracking.razor page. Again, there's a NuGet client package I added, ASP.NET Core, SignalR.client, and I haven't restored. That's why I got the squiggly. But all I'm doing here is just saying, all right, give me a hub connection. And then my onInitialize async, all I'm doing is saying, all right, start it up, or making sure it's not already started, and then saying, all right, I'm going to build it with the tracking URL that I have in my app settings. Make sure I can automatically reconnect. So this is all built into the Hub Connection Builder. And the automatic reconnect, building for resiliency, taking my cloud stuff in mind when I build it, and then saying on tracking message, whenever I get that from my Azure function, so when I send it out, here I'm saying, all right, SignalR, say this is a new message coming out. That's what you want to call it, the target, new message. When it comes out, my client, listen for a function or message that says it's a new message, and it's going to have this tracking message type coming to it. Once I got it, just populate some variables, and away I go. And then I start the whole hub connection up. And now I've added real-time communication between my client and an Azure function. Now, one thing I did kind of skip over, and I'm going to kind of skip over the entire talk, is authentication. So when I'm sending these connections out, I'm sending it to whoever registered. I should have added authentication to the whole thing, but that's another talk. That's like the Whirlwind Tour Part 2. But here we go. All righty. So now we're back in, and we want to talk about, notice how we had connection strings all over the place, right? We can get rid of those. And we can get rid of those with things called managed identity. Now, what a managed identity does, it gives your Azure services, it makes them like people. It animates your Azure services. Now, what it does is it puts them into Azure directory, and then what you can do then is give them, your Azure services, permissions to get access to other Azure services. So now we can start getting rid of, like our Azure functions, we had to know what the SignalR connection string was. We can get rid of that. We can just have that somewhere up. We can start getting rid of, if we had to talk to container registry, which we'll talk in a bit, we can just say, hey, this Azure service, we can have pull permission on a container registry. So we can start granting permissions everywhere. And it's also developer friendly too, and I'll show you how. All right, now we can get into, we have things that are, we kind of got rid of our connection strings with a managed identity. How do we actually get them out? We still have to pull them out. We still have to say, all right, I want to get at my stuff. And that's where we can start talking with configuration values and secrets. And to make things nice, we want to put them in one spot. And this is where Azure Key Vault and eventually app config starts coming in. So what is Key Vault? Key Vault is a centralized and secure secret store. You can version secrets in here. So eventually, like when you leak a secret, when I say you, I mean like me. If I'm at a coffee shop and somebody's shoulder surfing and sees a connection string or something, I can version it, redo it. Role-based access to it. App config. App config, think of it as a super duper app settings.json, but in Azure. And what's neat about that is eventually you're going to start scaling on, you're going to have different app services all over the place, several of them. They can all go in and read the same Azure app config and get their settings out of there. What's cool then is Azure App Config can talk to Key Vault, and it's built right in with seamless .NET integration where it fits right into the pipeline. So .NET, when you're writing your code, it's just like accessing the app settings JSON. All right, so that's what we're going to end up building now. We have a new rectangle in here, and that rectangle, broker is covered by it. All our app services are covered by it. And what we're going to do is that we are going to read out app config, which is going to talk to Key Vault, but it's really going to be just kind of seamless to our application. So let's take a peek. All right, so the first thing I want to show you is how that we would actually set up a managed identity. And so I'm going to open up like the PizzaConf checkout, which is one of our microservices that does the checkout itself. So actually to set it up and say, hey, I want you to be part of Active Directory, I would search for identity and then turn it on. And now it gets a principal ID. It's like, I am now an object. I can do stuff. I have rights. And then next, after that, we can do things such as go to Key Vault, which is going to be way down here. And then I have access policies within Key Vault. And you can see underneath application, all my PizzaConf dash, they're in there. And they have certain access policies. They don't have everything, like they don't have key permissions or certificate permissions. They just have like get and set out of the secret permissions. So these applications are limited in what they can do to Key Vault. They can get to it and they can get at secrets, but they can't get at everything. So let's take a quick look at the secrets. Like I said, like my checkout DB connection strings in here, it has a version, so if I do leak it, I can create a new version, cycle my connection string, but I can still access it, so my code doesn't know necessarily that I've leaked my secret. I can still keep on working with it. It's all developer friendly in that manner. All right, so then jumping up over to app config then. Again, access control. If I look at my role assignments, you're going to find out that data reader has my PizzaConf dashes in it. Cool. Gave them access to it to be reading stuff out of it. And if I look into the Configuration Explorer, all right, one thing I do want to call out is right down here, that little key. That key means it talks to Key Vault, which is neat. So that talks to Key Vault. So what it is just kind of passing through over to Key Vault. And I can give it a new name as well. And then I have stuff like cart URL in here, which doesn't necessarily mean it's protected. It just means it has a value in it. Keys mean it's protected, has super great encryption. Cart URL just has like plain text, something that we're not necessarily worried about leaking. Let's see how we would access it. All right, so what I'm going to do is I'm going to open up the checkout API. Open up the program. And then I have added two NuGet packages. One that's called Azure App Config. Let me double check to make sure that's what it is. Packages. It is called, well, one's called Azure.identity, and the other one is Microsoft.azure.appconfig. So those two NuGet packages, once they're together, let me access Key Vault and AppConfig. So when I'm setting up my builder in my pipeline here, all I'm going to say is, you know what, add Azure App Config to it, and then send in what the URL is going to be. So in the connections options, just say, hey, you know what, I want the app config URL, and then this right here, default connection string. This is what's super cool. It's saying, remember when I had things set up as like, you can read app config? What it's saying here, because Matt, I could read the app config as well, Azure App Config. It's using who I'm logged in to as Visual Studio to pass the token up. But when I deploy this application, it's also going to use who that application is, the managed identity, that token, and send that up. And so in my pizza checkout, I'm saying select. It's just going to bring back the checkout DB string for me. And then right here, I'm saying, you know what? Also send over the Azure credentials, the default Azure credentials, to Key Vault as well. So if I didn't do this configure Key Vault, Azure App Config wouldn't know what to send over. So right here, this is the key, so to speak, of getting to App Config and Key Vault. So this way now we can store everything up in the cloud as far as our connection strings and our regular app configs and get at them. All right, so we are whirlwinding around and we're going to keep on going. We have one last thing to talk about, and that's a one-stop shop for all your microservices, and that's going to be Azure Container Apps. And what I love about Azure Container Apps is, one, they're containers, right? So I mentioned before that we deployed everything to app service in containers. Well, now we can kind of lift and shift them to Azure Container Apps. But Azure Container Apps are serverless, which means they can scale down to 0, amongst other things. They can also scale up real easily, and they can scale up based on CADA rules, which is Kubernetes event-driven architecture, I think. But they have a bunch of rules that define how it spins up, which is based off of Kubernetes rules. So you think of container apps as built around Kubernetes, but real easy. You can version your container apps, and it also integrates with Azure Container Registry. You can think of Container Registry as like a Docker hub. Put your containers out there, you can pull back what you want. And then this is what I want to call out nice and easy Dapper integration. So what Dapper does, it gives you a way to build microservices that's essentially easy. You can do things like pub/sub. You can hit like cache. You can even do things like service discovery. So I'm going to show that off really quick on how I would do service discovery with Dapper installed. And all it is, I'm going down my PizzaConf, and I'm opening up program.cs. And then when I'm newing up my HTTP clients, what I'm saying is, hey, I got my Dapper, I want to get a Dapper ID out, and I happen to be getting that Dapper ID from app-config. I'm just going to say, hey, my URL is going to be localhost, so I'm not going to actually put that menu URL into app-config at all. So it's going to be HTTP localhost 3500. Pass in a Dapper app ID into the config headers. Same thing for the cart service. So both the cart service and the menu service due to Dapper have the same HTTP URL. They just have a different request header. So now Dapper knows enough to find these services for me because they're all deployed up into dotnetconf, and I have a container app environment with 3 container apps deployed to it, and Dapper is enabled, and you can see the app ID is that, and then Dapper container apps, the environment knows how to route them. And Dapper does a whole lot more, and it's amazing. So whirlwind tour. We got through all of it. That's what we look like right now. And there it is. Find out more at that AKA MS at the bottom, dotnetconf/whirlwind. Everything you ever wanted and more, it's all going to be there. Whew. I'm Matt Sokup, and we did it. Whirlwind tour of building .NET apps in Azure.
Amazing, Matt. Really quite the whirlwind. I mean, you walked right on over there, and then you gave us the tour, and you showed us all the things, and you had all those Azure services. Let's see what we have for questions rolling in. I didn't see too many, which is good. That means you explained what you needed to explain.
It means
but we did
talk
see
super fast.
Yeah, you talked. I mean, you didn't go over time, which we fully expected you to. So that's pretty impressive. But we do see some cool things popping up in Twitter. Of course, the digital swag is making its way around the interwebs, if you will. Like Martin here has the backgrounds on both his watch and his phone. That's pretty cool. And there's desktop backgrounds. There's all the different things. With our cute little new .NET bot, he's 3D now. It's 3D. I also saw something about what we talked earlier, the digital pet extension for Visual Studio Code. You can have a .NET bot hang out with you while you're coding. That's what it looks like. Cute little bot. Thanks, Angel, for showing us that. And a whole bunch of other people excited about Azure and container apps and the cloud. And we are now officially halfway through our 2 cloud hours. We have 2 more sessions coming up in just a few minutes. But before then, I just want to remind you, I know you've all heard it, but go to dotnetconf.net, get all the things you need. Go for the Secret Decoder Challenge. Tweet us, #.netconf for your questions with no longer Matt. He will now be back to asking the questions instead of answering them. You all went way too easy on him. We could have grilled him on Azure forever. And don't forget to join us for our code party / virtual escape room at 5 p.m. Pacific. So we're halfway through the cloud. We've learned a lot so far. We had Scott show us all of the things that he wanted to show us in the state of Azure and .NET 7. We had Matt now just give us this whirlwind tour of all the things, which I kind of followed. I did like the part where Matt was talking about how, your secret key can get right over your shoulder in your coffee shop. My secret key I just accidentally published to my GitHub, which I know you're not supposed to do, so don't do that. We do have more cloud sessions, and then we have the client sessions this afternoon starting at 1, which I am now affectionately calling the Maui Power Hour, even though it is 2 hours. And then the customer and developer success stories this afternoon. Tomorrow we also have themes. We don't have the same kind of mini keynote format, but we do have modernization. We have a whole bunch of other things, and they're all on the agenda on dotnetconf.net. And then we have our community sessions. If you didn't realize, dotnetconf goes through the night tomorrow for those of you in the USA. And so that also means through the morning or at normal times for those of you elsewhere. I know one of the .NET Maui team members is giving a talk at, I think, midnight our time, which would probably be early 9 a.m. or so his time. So that's pretty exciting. So definitely give the agenda a scroll. Make sure that you're looking at the website, you're checking all the links, and your digital swag. You're registering for your potential raffle 25 swag bags from our amazing sponsors. And you're getting your Code magazine subscription, which you are getting for free. Very exciting. Just like all those performance wins we saw in the web a little bit ago. Free. Everything's free. Oh, what's back there? Hold on. Are they eating? Is it lunchtime and I'm in here? Oh my God. These goofs. This is great. I like that we have the window in it this year so we can really see all the chaos behind. 2 Seattle Kraken hats. Nope, don't like it. So of course, thank you to our wonderful DevRel Studios team. Ryan, who's the one holding this giant camera right now, and everybody else who's here putting on this production. We're coming up on the 12 o'clock hour, which is kind of halfway. Not really. But we are going to turn it over to Melanie and Fabio, who are going to talk to us about building serverless applications with .NET 7 using Azure functions. So take it away.
Hello everyone, my name is Melanie Quinn. I'm Product Manager at Azure Functions team. I'm here today very excited with Fabio. We'll be talking about building service applications with .NET 7 and Azure Functions.
That's right. So we're excited to share a lot of news, a lot of new information about what we've been doing for particularly the out-of-product model and Azure Functions. So Melanie, what are we going to cover today?
For today, we have a pretty packed agenda for half an hour. Firstly, we'll start off by what are Azure Functions, then .NET on Azure Functions. And we'll drill down a little bit for .NET on Azure Functions, specifically talking about isolated worker process, as well as sharing some great work we've been doing to enhance isolated worker process and some updates. So we also remember earlier this year, we announced some .NET versions to be end of life. So we'll also be sharing the brand new migration guides with our developers to help customers migrating from the retired .NET version to .NET 7. And always feel free to share your questions as we go. And by the end of the session, we reserved about 5 minutes for Q&A. So if everybody's ready, let's get started.
Let's go.
Yeah. Oh, I know I kind of, gave away .NET 7, but I really want to share. I'm very excited to announce .NET 7 support in Azure Functions is generally available today. Yeah, this is a great news for our customers. So what does that mean? It means .NET 7 we recommend you can use in production scenarios, as well as you can take advantage of all the greatest and newest features of .NET 7 with Azure Functions. Although a little bit reminder here, we also made .NET Framework supported in Azure Functions before host a few weeks back. So I hope everybody catch up here. So I also want to have for our customers, because if you are a .NET developer, you may not be very familiar with what are Azure Functions and what the work we've been doing. So Fabio and I will be here to help you get to know Azure Functions as well as share the work we've been doing with Azure Functions. So back to your day when you are a .NET developer. Imagine the first day you start your job. So a lot of things, it's just very overwhelming. You need to start your project. So you start to set up dependencies, configurations, there are a bunch of stuff to do to just even before getting started your job. But as a developer, I know you want to build a very cool applications. So with Azure Functions, we provide a ready-to-code environment for you. What does that mean? mean, you still need to set some configurations, but it's much easier, and you can do so much more compared to what you did before in the past. With Azure Functions, it supports a lot of different triggers. So if you want to do, for some scenarios such as you want to build a new web APIs, we want to process IoT streams, we want to process file uploads, Azure Functions will have multiple triggers, will support your scenario. It also enables a lot of different integrations with Azure services such as Cosmos DB, Event Grid, and Service Bus, a lot more. So check out our documentation. As a .NET developer, we know you love all the IDEs, Visual Studio Code, and so much more. And those IDEs are cross-platforms. So it's very easy to enable you to be able to develop in Windows, macOS, or Linux. And it's not really end there, because as a developer, when you start to develop your applications, the moment you start to write some code, and you're expecting, okay, now what can I do in my code? How can I make my code available in the cloud, in my dev test environment? It could be in the cloud, it could be in the server. We provide multiple hosting options for you to deploy to the cloud. One of them being consumption plan. That being said, this is a pay-as-you-go model. You pay only for what you consumed, and it's very highly react to your requests. If you want to think of that, because this is a service offering, the backend infrastructure is managed by Microsoft Azure, and for you, you can save on cost. We also have some other options if you want to reserve your compute, such as Elastic Premium Plan, as well as App Service Plan. So those are options we provide for you to fit your business requirements. We talk about a bunch of stuff here. So what are Azure Functions? Azure Functions is a event-driven service compute service that accelerates your application development, as well as that enables our developers to focus on delivering value to your organization. You'll get that in a very second, because the internet experience that we provide to our developers enable you to leverage your expertise to use Visual Studio, VS Code. Those are the tools that you're familiar over the years as a .NET developer. Also, we provide command line tools. It's called Azure Functions Core Tools. Those three tools enable you to create your Azure Function app functions locally, develop, debug. Then you can push your changes to Microsoft Azure. We made the process very easy for you. Of course, modern days, we're also talking about CI/CD, DevOps, workflows. It's also support for GitHub Actions, as well as Azure DevOps. We provide native DevOps task, so you can use very easy integrate into your CI/CD workflow. What you can see as a developer, your inner loop is you can start using Azure Functions, using those IDEs, leverage your knowledge you already have as a .NET developer, and you can debug your application. And it's very easy to push your changes to Azure. And in the back, you can take advantage of the fully scalable service compute that we provided. We help you to make your life easier. Okay, I think I talked about a lot of end-to-end development experience, and I know so a lot of customers talking to me, they really also want to have a very friendly programming model. So one of them being isolated worker process. And I'm pretty sure for isolated work process, we have a lot of benefits aside from our user-friendly programming model. Fabio, do you want to share something with us?
Sure. So let's talk a little bit about what the isolated model is, right? So you talked about functions in general, shared a lot of good information about folks who may be new to functions, want to explore the service, but they have some familiarity with .NET. For some of our existing customers, some customers who have been using .NET on functions for a while now, they're used to what we call the in-proc model, right? That's traditionally how customers deploy and develop applications against Azure Functions using .NET, which means that we are actually running your code in the same process as what we call the runtime and the host. And with that, it comes with certain limitations and certain challenges that we're trying to address with what we call the isolated worker process model. So one of the key benefits is what you just described. It gives us a a different programming model than what customers are used to with the in-proc model, but something that is very close to what customers, it's a little closer to what customers are used to with the broader .NET ecosystem. So if you're working with an ASP.NET Core app, if you're working with a console app, you're going to feel right at home. No new concepts. You're just developing a .NET application, much like any other. In addition to that, you get some of the benefits with a more natural way to specify dependency injection, middleware support, a lot of additional benefits. But the key thing that I think we need to talk about is what enables us to make the announcement that we made today, which is the fact that the worker is completely decoupled from the host. So some of the host requirements that have existed in the past, particularly about the .NET version you could run on, those requirements are lifted. You have the ability to now pick new versions of .NET as they become available, as it is the case with .NET 7 today. So giving you a lot more flexibility on how you run, when you upgrade, what you get to preview, and when you decide to adopt and test new versions of .NET, and control over your dependencies as well.
Yeah, it's great. So do you also want to share what we've been making in progress? Because I know for last year, we made some really exciting progress here. So I really want to hear, can you share it with our audience here?
Yeah. So because of the fact that the isolated process was newer, there were some challenges with the in-proc model, but there was a lot of stuff there that we all loved and we all wanted to make sure we kept with the new model as well. And we heard a lot from customers, on some of the things that were important to them when comparing the two models, what they wanted to see in isolated. So the team has been hard at work working on a lot of performance enhancements to the isolated model. That includes both cold start as well as throughput perf optimizations. Durable function support is something that we've been working at. We have a preview of durable functions out right now, so you can try it out in the preview mode, and we have additional enhancements landing here very soon. Binding support is one of the things that we heard a lot from customers. We have this very nice model with the in-proc experience that abstracts some of the underlying SDKs away from you, give you a very nice binding experience and the ability to use some of the types coming directly from the service SDKs. So we'll talk a little bit about that today. We'll talk some more about that. And enhance the HTTP trigger support, giving you access to the underlying HTTP request, add access to some more advanced HTTP scenarios, which is something that you have in proc, and we're enabling some of those capabilities for the auto-proc scenarios as well.
Oh, that sounds great. Actually, we also encountered some enhancement for .NET Isolated Worker in this article linked here on the slide. And so one of them being SDK type binding, and I know for people who are in working process, they may be familiar with it. But you also share what their experience would look like here.
Yeah. So let's dive into one of those topics, right? Let's talk about SDK type binding, what that is. And if you are a seasoned, or if you are an existing Azure Functions user working with .NET, you may be used to the model where if you use a binding, let's say a storage binding, you have the ability to bind to specific types coming from the storage SDK, which for a lot of scenarios, it makes your function a lot simpler. It makes the process a lot easier. You don't have to worry about how to set up the SDK and connect to the underlying service. But the runtime and functions is managing a lot of that work for you. So with that, we want to bring that same familiar experience to the auto-proc model. So we want to enable the same level of binding access that you have in proc in the auto-proc scenarios, bringing that experience in. So everything that you do and you're familiar with the in proc model, when it comes to the binding types and the targets, we are bringing that to in proc. Keeping that SDK abstraction that we had with in proc, so a lot of the work on connecting to the services, retries, some of the defaults that you get and the behavior that you get from the host, that's all managed for you. And one of the exciting things that you get from that as well is a lot of performance benefits from moving to that model. So instead of going through an additional hop and have the bulk of the work done by the host, and have a lot of that data transferred to the auto-proc model to your worker, a lot of that's going to be happening locally to your function and managed by the auto-process environment. So a lot of benefits. Some of those are completely transparent and behind the scenes, but you get to benefit from a lot of the work the team is doing in this space here.
Yeah, I heard a lot from customers. They want to leverage their existing knowledge of in proc, and they also want to know how it works in isolated. They're also very care about the performance-wise things. I just can't wait to see the demo. Do you want to show us?
Sure. Let's jump in here and show a quick demo of this actually in action. This is a little sneak peek. This is something that we're going to be releasing soon as a preview, but I wanted to share with folks watching today, because it is something that we've been asked for several times, and it is an exciting thing for us to be sharing with you today. So what I have here is just a plain out-of-proc app. File new in Visual Studio, that's the template you get. So that gives you the basic framework to work with. In addition to that, so building on top of that, I've defined one function here that uses an HTTP trigger and uses the blob input. So far, everything is the same as what we've had before with the out-of-proc model, still very similar to what we have in proc, the attribute-based model here. One thing that you'll notice is different is the type that I'm using to bind to the client. So I'm binding directly to an SDK type that is directly connected to the service and gives me the ability to very efficiently communicate with that service and download the contents for that blob. And what I'm doing here for the demo is just taking the blob content, writing that out to my HTTP response, and that's what we're going to see on the way back. So let me just F5 through this. We are now debugging. We have core tools up, looking at the functions that I have defined. And for this particular function, if you caught the name, we are binding to the client. So this is the function that we're going to be using here. And I do have a breakpoint here showing us the debugging experience with this. And I have the ability to look at the blob client and see that type is hydrated, is set up and connected to my service using this container as an input. And all that means is that when this function is executed, that client will have access to the blob for me. So I can step through this code here. I've downloaded the blob. I don't have to specify anything beyond what was defined in the attribute. Now I have the payload, and if I let this go, we'll see the response here on the screen, just with the information that was in the blob. And just to prove that I was using a blob, we are working against local storage here. So we can take a quick peek at the blob that we were using, which is the exact content that was used in the input parameter that was used for my function. So in addition to the client, we also get a number of additional types that the blob extension will be supporting as well. So again, giving us parity with the experience that we had with improc, we have the ability to bind to a stream very efficiently, the ability to bind to a byte array also in an efficient way that gives us some performance benefits when compared to the previous model. So even if you had a workload in the past that you were just binding to a string or a byte array, those will improve just by taking advantage of the new versions of the extensions that have support for this new capability. And that this last example here shows an example of us binding to a simple POCO that was defined as part of my application.
That's cool. So I hear a lot of customers, they really want to use it, but I think now the question is really about, if you are already functions customers and you own functions v3 or even v1, how can we help customers move to .NET 7?
Sure. So not just for .NET 7, but a lot of the latest and greatest features that we've been working on, all of the enhancements that we've been talking about here, we've been working on migration guides and making those available, giving you some information on how to migrate from previous versions of functions to Azure Functions v4, which is where you have support for .NET 7 and a lot of the capabilities that we just discussed. So if you are on Functions 3.0, there's a link here for you. Use the Zaka link and you'll be able to find a migration guide that will help you get from 3.0 to 4.0 so you can take advantage of these new capabilities. If you're on the older version of Functions Functions 1.0. We also have a migration guide for you that also talks about migrating .NET Framework dependencies to Azure Functions 4.0 using the Autoproc model.
That's I think our customers are waiting for this for a very long time because they have now the step-by-step guidance to help them move. So also, somebody also asking, okay, so what's coming next?
Yeah, so earlier, a few months ago, a couple months ago at this point, we've shared a roadmap update. There was an update from the previous roadmap that we had shared when we released Functions before .NET 6 support. That update outlined a lot of the plans that we have as a team, which touched again on our intention to close as much as possible the gap between the in-proc and the out-of-proc models, provide parity when it comes to the feature experience and performance of both models, and eventually make the out-of-proc model the default because of all the benefits that it brings in addition to the work that is being done to close the parity gap that currently exists. One thing that we wanted to make sure was clear, and we wanted to emphasize with the last update, is that a lot of that plan will be conditional on us being able to actually close those gaps, being able to actually meet the requirements and the expectations that customers have. We are not going to be pulling functionality away from customers and blocking them from continuing to use functions with all of the features and all of the workloads that they need to bring to us. So we shared that update a few months ago. We have another update coming in at the beginning of the year, but this slide here kind of shows the possible outcomes, what we have for the next version of functions, which will either be with in-proc model built in and still supporting the rich experience that we have with in-proc, or if we have parity with the out-of-proc model, that will be the default experience in functions at that point.
A lot of things actually hear from the customers is we listen to our customers. So if you have any feedback you want to share, we do have a function roadmap update. This is a link in this slide, so it will be in the description down below, where you can create an issue because it's the same GitHub repo. You can share your feedback there, as well as just keep an eye on what's coming in the future for .NET on Azure Functions. Of course, if you want to get started on .NET 7 with Azure Functions, we have the documentation articles here, so you can use whatever the clients we want to work with, especially with the tools you're familiar with. So we're here to help you. Please feel free to leave your questions here, and we're really happy to take any questions. And otherwise, I hope you enjoy the rest of your conference.
Awesome. That was great. Thank you both so much. We do have a few questions that rolled in via #.NetConf on Twitter. Great. Matt, you want to ask some?
Yep, we'll start off here from Alo's Tony. What's the difference between Azure Web Jobs and Azure Functions?
So Azure Functions is actually built on a lot of the same underlying foundation as Web Jobs. So Azure Functions is built on top of Web Jobs. So if you're familiar with Web Jobs, there's a lot that you can leverage. There's a lot that you can apply to functions as you start using functions. The key difference there would be some of the triggers that we support in functions and the hosting models that you have the ability to use in functions. HTTP scenarios, if you have an HTTP requirement, it's something that you want to consider using functions for. And if you want to take advantage of the consumption model that Melanie mentioned earlier, it's one of the key things that differentiates functions and the more traditional web job scenarios. Functions would be a better option for you at that point as well.
All right, so we got one more for you. Actually, we have two more. One just came in, and this one's from Jeff Fritz. I'm not sure if we know who he is, but all right. So, but anyways, he's a huge fan of Azure Functions. And are there any changes to the consumption model for .NET 7 and the V4 runtime?
No changes in the model itself. And if you're familiar with the out-of-proc experience, the same experience that we've had supporting .NET 6, .NET 5, that remains the same. So that's going to be the exact same experience there, except for you have access to .NET 7. From a billing perspective and the execution model, that is also identical to what we've had in the past. So no changes to the model, the consumption model being announced at this time.
All right, so we have one more question coming in, and this one comes from Roman. All right, so this one might be a no comment just because it's asking about the future, but when can we expect authentication and authorization in Azure Functions to be aligned with ASP.NET API?
That's a great question. So it is something that we have been evaluating as a team, so that better integration with ASP.NET Core as part of Functions. I don't, unfortunately, have an ETA that I can share. It's not part of the parity work that we've been doing, as it isn't something that is currently supported in proc. But it is certainly something that we have been hearing feedback on, questions on, and we are evaluating as a team. I would encourage you to go on GitHub, continue that conversation there, because we use a lot of the feedback that we get on the open repos to drive a lot of the work that we do.
Great.
Great, so thank you so much, Melanie and Fabio. We really enjoyed having you here, and we always love hearing about Azure Functions. So thank you very much.
Cool. Well, now we are getting into our final session of the cloud section. The final cloud section session.
The cloud.
The cloud. We have a few minutes before we bring Anthony on to talk about containers, I believe.
Azure Container Apps.
And he doesn't mean the containers that come in on big ships.
No.
He means container apps.
Container apps.
This is out of my realm. And I've been seeing some questions roll in on Twitter, #dotnetconf, about container apps and how to containerize some of the demos we've seen earlier.
So if you just hold tight for just another half hour, we'll be able to, you might have those questions.
Use .NET with Azure Container Apps. Let's get into it. So we're seeing more and more developers use the containers to develop and deploy their applications. And we're also seeing more teams leverage the microservices architecture to be a little bit more agile in the way that they deliver their software. So Azure Container Apps is a new service in Azure. We became generally available about 6 months ago. That allows you to build serverless containers for microservices. So it's built on top of an open source foundation. So it's built on top of Kubernetes, as well as a bunch of other different open source projects. And not only that, you can use open source tooling to build your applications. I already mentioned containers, but you can optionally use things like Dapper, which we'll get into a little bit later, to build your applications as well. And because we're an abstraction on top of Kubernetes, you can focus a lot more on building your apps and not have to worry about managing any infrastructure. And there is scaling built in automatically for basically you can scale your application based on any event that you can think of. So and there's support for scale to zero, so you don't have to pay for anything if your application is not running at all. And Azure Container Apps comes with a free grant, a lot like Azure Functions. So you have, I think, a couple million requests for free, as well as a certain amount of CPU and memory usage every month that are included for free as well. All right, so let's look at what kind of stuff you can build with container apps. So we already talked about microservices, and that's that's just a bunch of services that are running that can communicate with each other either synchronously using things like HTTP or TCP or gRPC, or they could communicate asynchronously through something like a queue. And all of these things can scale based on the events that they're processing. So that's pretty cool. And you can also develop and deploy standard web applications as well as web APIs to Azure Container Apps. And you can, you have access to things like custom domains, TLS certificates, as well as integrated authentication. And all of these apps can scale based on the number of concurrent HTTP requests that you're that you're receiving, and you can configure that per app. So if you have an application that can scale, that needs to scale a lot, you can actually adjust that. And you can also run event-driven processing applications on container apps. And one of those, like a pretty common example, would be an app that reads from a queue. And for that, you can actually have container apps scale based on how many messages are in the queue. So you can actually scale out if the workload increases, and then scale all the way back down, maybe even all the way back down to 0 if you have no messages in the queue. And we can also run traditional background processing on Azure Container Apps as well. That's anything that's kind of just processing things in the background, and we can scale those based on CPU and memory. So before we dive into demos, I want to kind of just give you a quick overview of some of the concepts within container apps. As you can see in this diagram, it's a little bit daunting, but we're going to break this down. It's actually not that difficult to understand, hopefully. So all container apps live in a container apps environment. And an environment is basically an isolation boundary. All applications that you deploy to an environment share the same virtual network. And you can also configure them to use the same logging and observability as well. So you can actually see logs and observability metrics for all your apps within an environment in the same place. And as I was saying before, you can deploy one or more container apps to a container app environment. And a container app is basically a microservice, or like an app that you might deploy. So you might have one app that is a web front end for your entire application, and then you could have an order service API as deployed as another app, and you might have an inventory service that might be reading from a queue deployed as a third app. And then within each app, you can actually create one or more revisions. And revisions allow you to, if you want to kind of test out something before you make it live, or you want to do A/B testing, or you want to do blue-green deployments, they're great for that. Typically, you would just have one revision running of your app at the same time, but you can also have more than one revision running if that's better for you. And within each revision, you can run one or more replicas, and that depends on the scale rules that you have set for your application. So depending on how much load your application has, the scaler will decide to scale your revision in or out to the number of replicas that it needs. And then finally, within the replicas, you have our containers. So typically, a single container app or a revision has a single container defined, and that's just with the containers running your web app or your background job or something like that. But you can actually run more than one containers together, and that's typically what we call a sidecar pattern. So you can have a main container that's say a web application, and then you can run a sidecar a container that will, for instance, capture logs and ship them off somewhere else. Those are really useful for that, and those run within a replica. And as I was saying earlier, you can do things like A/B testing with revisions within Azure Container Apps, and this is because we have Envoy built in as an ingress, so you can configure that to route all the traffic to a single revision, or you can actually split the traffic amongst multiple revisions. So enough looking at PowerPoint. Let's look at some demos. Right, so let's go to Visual Studio. So here I have a web API project in .NET 7, and I literally just went file new project, and then I chose web API, and then I went ahead and published this to Azure using just the right-click publish mechanism. And then you can see here that it's already been published, and if I click here, it will hit the website. I actually have to go to the right path. And you can see I have some random weather information showing here. So let's take a look at how we can actually build a front-end application that is going to get deployed to the same container app environment that will talk to this API and display the weather graphically. So in this Visual Studio here, I have another application that all it's doing is just kind of making a call to the weather API that I have in container apps, and then it's displaying that information. So maybe the best way to show it is to just run it. So I'm just going to F5. And I've also configured a Docker file for this project as well, so it knows how to build a container. But if you want to try to use the new .NET 7 support for building containers, that should work as well. So yeah, so you can see it's displaying the weather data here, and if I take a look at the logs, I can see down here, it's a little small, but you can see there's actually making a call out to that service. All right, let's see what it's going to take for us to deploy this to Azure container apps. And we're going to try to do this a little bit more properly. So, whoa, what did I just do? Last time, or for the other app, I just did a right-click publish, which some people frowned upon. I might have already gotten some complaint emails come in because I did that. So this time I'll try to do this a little bit more properly using GitHub Actions. So I'm going to go do the same thing as before and right-click publish, but I'll choose a different option at the end. And sorry, I got to shrink my screen here because I have different scaling happening on this screen. All right, so I'm going to choose Azure, and I will choose Azure Container Apps. In here, I should see a list of all my container apps that exist. I can create a new one. That takes about a minute or two. So I've already created one, and you can see I've done some practicing here. And I'm going to choose Weather Web, so that should be the right one. And then I also have to choose a registry. So the GitHub action is going to build a container image out of my application and push it to a registry. And then Container Apps is going to run the app from that image. So I will go ahead and choose this registry here, click Next. And now, if I chose this option, I'll be able to just click a Publish button and send the app up to Azure Container Apps. But this time, I'll actually set up a CI/CD workflow using GitHub Actions. Go ahead and click Finish. And it's going to do a few things. It's going to set up my GitHub repository. So one thing I didn't mention before is that this application I've pushed to GitHub. So it already has the upstream set up. And what it should be doing right now is that it's basically setting a bunch of secrets on my GitHub repository so that when I run my GitHub action, it will have the right credentials to deploy my application. And looks like it's all done. I'm going to click Close. So I have to do one more thing, which is to push the workflow that it generated for me to GitHub. So I can take a look here. This is the workflow that Visual Studio generated for me. And I'm just going to go ahead and commit that workflow. I'm going to commit it and push it to GitHub. That looks like it's happening. Thinking about it. Okay, it's done. If I go back here and I refresh, it's actually going to query my GitHub workflow. So you can see my workflow is ready. And within a little bit longer, yeah, the workflow has started running. So let's take a look at this in GitHub. And you can see the workflow is working. it's running. It's gonna take about 3 minutes to run. It's gonna build the container image, push it, and then deploy a new container app revision using that image. While that's happening, let's take a look at this application in the Azure portal. So like I said, the Azure the application has already been created. I can click here to open it up. It's still kind of showing the welcome page because the workflow is still working, or it's still running right now. And let's take this time to go over some other features in container apps. So you can really easily get access to metrics of your application, so you can see exactly how things are going in your application. In container apps, you can use the authentication feature to add an identity provider. So if you want to protect your web application using things like GitHub or Apple or Facebook, you can really easily just add one or more identity providers here, and it works just like the authentication features in services like App Service and Azure Functions. And if your application needs secrets, this is where you set it. We're going to take a look at ingress a little bit later. In my application, I used Visual Studio to create my GitHub workflow, but I could have also used this portal here to create a GitHub workflow in my repository as well. And we're also working on support for Azure DevOps. And I can create a custom domain for my application. And I can also enable Dapper in the portal here. So we're going to talk a little bit more about Dapper in a little bit, but you can actually configure the app ID, the port, all sorts of things that you would need to configure for your Dapper application to work properly. And then I can also turn on managed identity in my application. And I can use this managed identity in my code to talk to things like SQL database or Cosmos DB, as well as things like storage, or really kind of any Azure service these days. And you can talk to it without storing any secrets in your application, so you don't have to store the connection string. You can use this identity to call those services instead. And you can also use this identity to do image pulls from Azure Container Registry. And we also have preview integration with Service Connector. And Service Connector allows you to, with a couple of clicks, add and link a like a database or something like that that you might want to add to your application. And down here, you can see the different revisions that we have in our app. Looks like the application has already been deployed. Let's take a look at the workflow. The workflow is now green. Things are looking good. Looks like I've stalled enough. Let's take a look back at the welcome page here. So if I go ahead and refresh this, it now shows our weather application that was deployed through GitHub Actions. So as you kind of might have noticed earlier, I kind of went through a little bit fast. You might not have. Currently, my backend API for the weather is actually public, and it doesn't need to be public because the ASP.NET application that's acting as the front end can actually call this within the same virtual network without actually going out to the open internet. So let's configure that right now. So I'm going to go over to my API application, and I'm going to click on its ingress blade. And as you can see right now, it's accepting all traffic from anywhere. I can go ahead and change this to limit traffic to just the container apps environment and click save. And it's going to take maybe 30 seconds for this to happen. So now after this is done, I should no longer be able to hit this endpoint from the public internet. So if I go back here and I refresh, you can see that I can't hit it anymore. And let's see what happens to the app. You can see that there's now an error. So we can use this opportunity to show you some capabilities within container apps to help you troubleshoot your application and see how we can fix this. So back in the portal, and this is now for my front-end app, so this is the app that's failing currently, I can click here to actually open up a log stream. So this connects to one of my containers that's running in my app. And if I go ahead and clear it, and then I just refresh this error page again, then hop back here, you can see that a bunch of logs appeared. And oh no, keep pressing whatever button I've been pressing to minimize my screen. Let's bring this back. Back. All right, it's back. So you can see that I'm actually calling this URL, and something appears to be wrong here. Let's see what's going on. So another thing that I can do is I can open up a console into one of the containers that are running for my app. So I can go ahead and connect to it here. And then I can just use a curl command and paste in the URL I just copied. And I can see that I'm getting a 404. So it's actually hitting the ingress, and the ingress is like, I don't know, I don't know of this address that you're trying to get to. And the reason for that is that when I changed the API to be internal, I actually got a new host name for it. So I'm actually going to copy the new host name, and then come back here, and then I'll curl again, and I'll paste in the host name I just copied, /weather forecast. And now I can see that the proper way to connect to the service now is to use this new host name. So let's fix that. So I can go over to my revision management, and I can create a new revision. So, so what I'm currently looking at is what the current revision looks like, and I can go ahead and make a change to it. And the change I want to make is to add an environment variable. So I'll call this weather URL because that's what the app is expecting. Manual entry, paste that in /weather forecast. Click save. And then I can click save here again, and it's going to go ahead and deploy a new revision for me. So that's going to take about maybe 30 seconds or so to do, or maybe sooner. So you can see that the revision is now provisioning, and we recently added support for zero downtime deployments. So it's actually going to keep the old revision up and send 100% traffic to it still until the new revision is up and ready and running. And if you have any health probes that you've defined for that application, it's actually going to wait for all those probes to pass before it redirects traffic to it. So now you can see that the provisioning is happening. And pretty soon, the new application or the new revision is going to have 100% traffic. Let's see if that's happened. I'm going to go ahead and refresh it. You can see it's working again. So that's how easy it is to deploy a new revision to your container app, as well to debug anything that's happening in production. All right, let's get back into slides here a little bit. So, what we just deployed there was a simplified version of what you're seeing on the screen, which is a pretty typical application that we see customers deploy. You can see there's a UI running as a container app down here, and you can have an order service that is placing messages on the service bus topic, and then a loyalty service is reading it. And Azure Container Apps integrates with a project called Kada for its scaling. And Kada comes with a lot of different scalers. So what Kada can do is it can actually listen to the queue that you are scaling, or that your application itself is listening to. And then based on the number of messages that are in the queue, you can actually decide whether to scale your application out. So how it works is that Kada is running in your container apps environment, in this case, watching the service bus queue. And then if it sees that there's a lot of messages in there and it's backing up, it's going to go ahead and scale out my loyalty service so that it can process the messages quicker. And then when it notices that maybe there's no more messages left in the queue, it'll actually start scaling back in my application. And if I've configured it to scale to 0, it'll actually scale all the way into 0. That's how Kata works. And I also mentioned that Dapper is built into Azure Container Apps. And you don't have to use this. It's optional. You can see that the application that I deployed did not use Dapper, and it still worked. But Dapper is a nice little toolkit or a runtime that allows you to, that simplifies a lot of the things that you might want to do when you run microservices. So things like service-to-service invocation, state management, and pub sub. Those are all kind of provided by Dapper. And how Dapper fits in is that if you enable Dapper in your container apps environment and in your applications, we will run a Dapper sidecar next to your application. So now instead of me talking, like the order UI talking directly to the order service, it's going to call to the Dapper sidecar and it's going to in turn call your other service. It's also running Dapper as well. And then for the order service, instead of it talking directly to Cosmos DB as its state store, or the loyalty service talking directly to Service Bus, for its pub sub, it's actually going to do this through Dapper. And that creates a nice abstraction. So if I wanted to run this entire application somewhere else, and I decide to swap out, maybe I'll swap in Redis for Cosmos DB, or I want to swap in Kafka instead of Service Bus. I can do this all just by configuring Dapper, and I don't have to change anything in the application itself. That's pretty cool. And I'm going to show you a really quick demo on how Dapper fits into Azure Container Apps. If I go back to my portal here, I have deployed another application. It's a pharmacy application. It's just constantly kind of creating orders and then fulfilling orders. And we can actually look at the architecture. It's a much larger application. It's more representative of what people are deploying today in production. And I want to show you how we can actually observe and monitor this application because Dapper is enabled. So Dapper integrates with Application Insights, and an Application Insights has a really neat feature called an application map. And here you can see the application map for the app that we were just looking at. And I can zoom in and out, and I can do things like click into anything to actually drill into some more information about it. I can look at how this particular receipt generation service is doing. And if I want to, I can go and investigate its performance. And I'm presented with some really rich information about this service itself. Anything from its load to its, basically its response times histogram, as well as things like, how each call is doing. And I can even drill into a specific request if I wanted to. And if I look at a specific request, I can actually see that entire request from when it comes into the order service to when it kind of goes through pub sub and kind of reaches each of these services as they process them. So you actually get this end-to-end view of my application, and it allows me to kind of see how things are going. And then it makes it hopefully a lot easier to troubleshoot because it makes it really easy to kind of see that something is wrong and then drill into it and find the error itself. So hopefully, in the last 20 minutes, you learned a little bit about how Azure Container Apps works and how you might be able to use it with your .NET applications. If you want to learn more about Azure Container Apps, go to this URL here. It's going to land you on our Container Apps documentation, so you can learn more about how you can do more with Azure Container Apps. Back to you, Maddie and Matt.
Great. Thank you so much, Anthony. We did have a ton of questions roll through with hashtag .NETConf on Twitter. So let's try and knock some of those out, huh?
Indeed. Thank you again, Anthony. Great session. And the community loves container apps. So we'll start off with one from Stuart Wells. And it is, when to use container apps versus Azure Functions for a web app that is in constant use?
I think for an app that's in constant use, I think both services would do great. I think it really kind of boils down to whether you want to use the Azure Functions programming model, or if you want to, for instance, just spin up an ASP.NET Core application and deploy it, as a container. Both of those are valid. Azure Container Apps also has a form of serverless billing. So, and then you can also keep a container app warm as well if you want to do that. And if your app is just sitting there not doing anything, it actually qualifies for idle pricing. So even pricing-wise, the two can be quite similar.
Great. This is a Mac question, Anthony. So how do I go about keeping my container app warm? Is that a health probe, or how do I do that?
So you can do this by just setting your scale rules. So by default, I think the scale rules are 0 to 10. And then depending on what kind of rules that you have set, or the scale limits are 0 to 10. And then depending on what rules you have configured, it's going to scale between 0 and 10. But you can actually set the minimum to, say, 1 or 2. And so it's not going to scale to 0. So there's always at least one replica that's ready to go. And like I was saying before, if that replica, if your app is scaled all the way down to that minimum replica, and that replica is not processing anything, that means not receiving an HTTP request, or not using a CPU or network, it's actually going to bill you at a much lower idle pricing.
Okay, cool. So we have another question coming in from Zero. All right, so when will container apps deployment be supported on Project Thai?
That is a good question. I'm not sure whether we looked too much into it. I know Mike, who was going to present this talk with me, was working on things related to Project Thai before. So he probably knows more. If you follow up with me on Twitter or somewhere else, I'm happy to kind of look into that for you.
Great. And Anthony, we're keeping on going because container apps really has resonated. So what are the benefits of container apps over AKS?
Oh, that's a great question. So container apps runs on top of AKS, as I kind of mentioned briefly earlier. And it provides a bunch of abstractions. So you as a developer don't have to worry about managing the infrastructure yourself, but you still get a lot of the the capabilities of running your app in AKS. And so I would say, if you don't want to manage any infrastructure, you can start with container apps. And because your application is made up of a bunch of containers, and even with the scale rules and things like that, or if you decide to use Dapper, all of those things can run in an AKS cluster if you decide to change your mind and move to AKS. And you can also move in the other direction as well.
All right, so we have another question coming in. And so what's the local development experience looking like for container apps plus Dapper? So how easy it is for me to develop and debug locally?
Yeah, so Dapper has ships with a bunch of tooling, including a CLI. And it allows you to basically run Dapper locally and then start each one of your applications with basically a Dapper sidecar next to it. So you should be able to run quite a few of these services locally and test it out without deploying your app.
All right. I think those are all the questions we got. Anthony, we got a lot of people saying good job. They love Azure Container Apps. So great session. Thank you very much. That was great.
And that concludes our 2 hours of cloud.
The cloud.
Oh my goodness. Besides your session, what was your favorite part?
You know what, that's hard to say, but I love Azure Container Apps because it's brand new. And I also love Azure Functions. They're both kind of serverless, and they can scale out or they can scale down. They can do whatever they want or whatever you want. So, yeah.
That's pretty cool.
Yep. So you know what I really do like? I like Key Vault. Key Vault's one of my favorite things in the whole wide world because you can keep your secrets secret, but it's super easy for a developer to get at it. So it doesn't really make the developer experience more difficult because you have that, excuse me, the default Azure credential in there. Just sign in to Visual Studio, and then away you go. As long as you gave yourself access to the actual vault.
I'll have to remember to do that next time.
Yeah, well, no, that's really me.
That's pretty cool.
Yeah. So, is there anything coming up?
No, I mean, we're as we've said, and for those of you who are joining us, I know some folks are just waking up on some other coasts. So welcome to .NET Conf. It's the 12th ever .NET Conf. Everything you've seen today so far is recorded and will be uploaded to YouTube. So you're welcome to go to dotnetconf.net, get all the details, get the links to our raffles for our swag bags. We have 25 swag bags our sponsors are giving away. Everyone gets a free Code Magazine subscription if you go to dotnetconf.net, and then there's a URL there somewhere. We have the Decoder Challenge, so you can go win stuff from that. We have the completely free GitHub repo of digital swag. And what am I? Oh, the virtual code party.
Yes.
Escape room.
Escape room. I don't know how that works. I hope, you know what, if it was me, I would just get totally lost. You'd have to like code your way out of it. Like, all right, Matt, write a for loop. Like,
oh no, I would be stuck forever.
I'm stuck.
Yeah.
I'd be doing if
one.
Yeah.
If two.
If false. How come it doesn't go in? So, and there's also one more thing that's going on out at .NET is you can actually go through a survey itself and let us know how we're doing.
Oh yeah.
So we take all comments coming in for very seriously. We read through each and every one of them, and we use it to improve next year's conference.
Yeah, and it's you can talk about sessions that you liked, that you wanted to see more of. Let us know. We always are taking this feedback, and a lot of your feedback is actually the reason we're doing these mini chunks of time.
Yes.
Where you have a keynote for ASP.NET, and then 3 more ASP.NET sessions, or Blazor and whatever. So, of course, we read it. It's a good time.
And the URL for that is aka.ms.NetConf survey 2022. What we lack in brevity, we make up for in obviousness.
That's pretty good. I like that. That was slick.
Yeah, you like that? I just came up.
Oh, my goodness.
Practiced it all night.
Well, we're coming to the end of the cloud.
The cloud.
But you know what time that we're coming up on, Matt?
What time is it?
I don't want to start too early, but it's Maui time. Let's go. Everybody, welcome to 2 straight hours of .NET Maui content, otherwise known as client. My wonderful colleague Dave, who is on Twitter right now on his phone,
actually
is here.
I'm downloading the latest update of the Snippets application.
What?
Right here from Naweed. He has been updating Snippet. Is this what we've come to? This is it? She got me to wear the shirt, so I told her she had to do something extra. So no, this is a beautiful application for all things snippets. So code for beautiful UI. It's both a website as well as now it's a mobile app. So check that out. It's also free. So if you've got free for contributors. So if you've got a great app idea or XAML or C# UI, submit it to Snippets.
Wow. All right, put your phone away.
Yes, ma'am.
It's State of .NET Maui time.
Yes,
I am
ma'am.
Maddie Monaquilla, and when I am not standing on the other side of the studio, I am a PM on .NET Maui.
I'm David Ortnow. I am also a product manager on .NET Maui and Xamarin and .NET and all the things that intermingle. And we're here today to give you a State of .NET Maui presentation, starting with, appropriately, what's going on in Maui. So,
oh my goodness.
Would you like to jump into the last 6 months?
I would love to.
Can you reach the
Tilt
cursor?
this over to me. There we go. .NET Maui. So .NET Maui has been released, GA, general availability, for 6 months now.
Yes.
So we want to give you a quick summary of all the amazing things that have happened. First and foremost, you all love it, so thank you. We've really been enjoying watching our usage just grow. That line is going in the correct direction.
Yeah.
If you can't tell, up. That's what we want to see. And not only the actual usage of Maui, but the interest in Maui as an open source project has grown super, super rapidly. So if you look on this chart on the right here, the red line with the circles is .NET Core Core's star history on GitHub, so since it was open sourced. And the blue one is Maui. So when we started Maui, many years later, it shot up to almost the same amount of stars as .NET Core. Within, what's that, 2 years? That's pretty good.
Absolutely. Well, and I think it also speaks to not just the demand out there from companies and developers for something like .NET Maui, but the popularity of Core itself, because we are built on. This is the unification. This is why we came together, so that we can benefit from all the same performance things that we heard about in the keynote and everything else you've seen really to date so far today.
Did you say performance?
I might have.
That's everyone's favorite word today, so we've heard. There have been a lot of great performance talks, so we would be remiss if we didn't talk about .NET Maui performance, at least for a second in our state of .NET Maui. There is another session in an hour and some numbers from one of our engineers about performance. You can check out that same engineer, Jonathan Pepper's amazing blog, Maui 7 Performance, because since we're part of .NET, Maui shipped today with .NET 7. So we have a whole new Maui coming out. Very exciting. Maui, by the way, not just Hawaiian, but also multi-platform app UI. And with .NET Maui in .NET 7, you have 51% faster rendering of your pages, which is pretty cool. And one of our benchmarks is the lols per second, the amount of LOLs we can throw up on your screen. And your scrolling's faster. So on the right here, it's the GPU load. So lower bars are better. So you can see with .NET 6, the bars are tall. That means it's not as good. .NET 7, they're smaller, which is better.
And importantly, that faster scrolling was benchmarked and really targeted at lower end Android devices, which is really where this becomes more and more apparent and more of an issue. So in some markets, those devices are more prevalent, and so we need to make sure that we optimize for them, as well as the brand new Pixels and Samsungs and whatever the hotness is on Android these days.
Yeah, that's awesome. And of course, Maui is not just an amazing SDK and toolkit that you can use to build your mobile and desktop apps, but it also is a complete product lifecycle to get you from writing your code all the way to shipping it out to your customers and all the things that come after that. So in all of these 5 phases of development, you have developing, testing, building, distributing, and monitoring. There are solutions out there for .NET Maui, and there are more by the day. We were updating the slide up until the last minute because we keep hearing new things that have been coming out. Of course, with developing, you can use Visual Studio and Visual Studio for Mac 17.4, shipped today, both with general availability, .NET Maui tooling in the stable channel. But you can also use Microsoft DevBox, which is a fantastic new offering, if you hadn't heard about it, from Ignite, where you can actually load up basically like a fancy VM that does the development stuff. It's very cool. Someone on our team actually opened a DevBox on his iPad and then developed an iPad app on his DevBox on his iPad using .NET Maui. So that was pretty cool.
Yeah, absolutely.
So you can develop anywhere you want, of course, and then you want to test. You can use NUnit for testing. And coming soon, we do have App Center support for Xamarin UI Test .NET Maui. So I know those of you who are waiting for that, hang on, it's coming. We're very excited about it. And then building all of the places you might want to build your app, whether it's Azure DevOps or GitHub pipelines. That's what this blue logo is, by the way. I didn't know what it was. And then I realized it was GitHub pipelines, or GitHub Actions, excuse me. And I was very confused, and now I know, which is exciting. And of course, App Center for building. Distribution, not only to the stores, the Microsoft, Apple, and Google stores, but also to their distribution mechanisms for beta testing. For example, TestFlight with iOS. Google Play has in a beta built in. The Amazon App Store and App Center, if you want to distribute via that. And of course, monitoring your application. So a bunch of companies, all different sizes and shapes, are out there shipping things for how to monitor your .NET Maui apps. On here we have Sentry, App Dynamics, and of course the Crashes and Analytics SDK from App Center, which is in preview for .NET 7 now. Very exciting.
And you never really know how important, I mean, you know it's important, right?
Yeah.
But you don't think about these things because you've had them for other, Xamarin, for example. But then, we were in the early previews of .NET Maui, and we're like, yeah, we don't have anything for error reporting. Yeah, you can't publish the app. You can develop it, but you can't publish. And granted, you're a preview, right? So that's just part of the development of the product that you develop with. But this is, this slide is a great testament to the state we're in today. It's a state of .NET MAUI.
The state.
That you have the things you need at your disposal to go through the entire DTBDM process.
Yeah.
That's not going to stick. That's not
going to stick. Nice try, though.
Yeah.
And there's way more than just those ones. Our entire ecosystem has been loving .NET MAUI. We have been every day hearing of new packages, new community members, new apps, all these different things. But these are just some of the amazing logos you'll see of open source or otherwise projects that now have support for .NET MAUI. We know for those of you who are on Xamarin, you want to get to MAUI because it's cool and it's awesome, and you've been waiting for some of your packages to get ready for MAUI, and they are. That's part of the reason we GA'd it 6 months ago, so that we could get all of your packages in your ecosystem up to date. So it's pretty cool. Some good ones on here. I don't know. Pretty cool logos too.
I love the Strawberry Shake, for example.
Cool.
That's a GraphQL library. I don't remember what the cats are. Those are different cats. But we've got of course the major component vendors like your Progress to Lyric, Syncfusion, Grile, DevExpress, Improgistics, Esri, and on have offerings as well. But there's some new cats on here.
New cats.
And that's what's really exciting to me is that we're not just seeing Xamarin libraries come forward, but we're seeing new innovative players in this ecosystem. So there's been some inspiration ignited with .NET MAUI, and that's cool.
That's cool. And of course, since it's all just .NET and .NET 7, anything that runs on .NET 7 kind of core cross-platform, we don't really call it core anymore.
Yeah.
But that will work in your MAUI app too.
Absolutely, and some of these, James Montemagno probably is responsible for quite a few on the screen here. Mostly the blue boxes, I think, the ones that you can make money through your app and you can rate your app. Once he had migrated those to .NET 6 back in May, when that happened, the migration to 7 doesn't really need to even worry about it because your 6 works on 7. So the pain of the Xamarin .NET Framework transition to .NET 6, it's not the same story going from 6 to 7, 7 to 8, etc. Yeah. It's very, very smooth. Your upgrade of your .NET 6 MAUI apps, change the 6 to a 7, probably just fine.
That's pretty nice.
Yeah.
Well, I'm going to turn your laptop back in your direction.
Please.
And let's talk about some customers that are using .NET MAUI today.
Yeah, so we get asked this question a lot. Who is using .NET MAUI? Can we see any? Because I don't know. And you know what? We sometimes have a hard time as well finding them in the wild, right? You got to crack open a file and do some reverse. We're not going to mess with that.
Right.
But we do talk to a lot of customers all the time about what you and your companies and you as developers for other companies are doing with .NET MAUI, and we've gone through the steps to be able to share some of those stories with you today. Because sometimes you just can't talk about these things publicly. People want to protect their info. So I want to start with first-party apps. So a really cool app here from Alexandre Costas in Brazil. I believe he's based in Brazil, right? But he works for us now, and he made this app during Hack Week. For people that are with partial or total loss of vision, when you are in need of a volunteer to just help you out for a task that you might have. The canonical task that he presents is, I need to go shopping through the mall. And I'd rather have somebody guide me through the mall than have to do it by myself. And so using this app service that they've built and this accessible app, I don't know if you can see this on the screen, but it's got the focus rectangles around the UI elements and everything because it's fully accessible, and .NET MAUI is accessible by default. Shane Newell and Rachel Kang have done a great job on the engineering team working with customers and with our internal validation teams to make sure that our .NET MAUI apps that we test with pass all the certifications, all the benchmarks for an accessible app.
That's awesome.
So you get that by default, And here's one example of a Microsoft team making an app. It wasn't just Alexandre, it was he and others working on this app. Also, the Hack the Hire application is from a group of recruiting and other Microsoft employees kind of in the Atlanta area, I believe. And they saw a need to be able to help find and promote talent from within the Black and Afro-Latinx communities to bring them into Microsoft. You know, we highly value the diversity of perspective as well as experiences and backgrounds. So being able to have teams that really represent that is super important to our culture and to the value of what we build as products. So this is a beautiful app. These screens don't do this justice. It's actually quite a few features. Cool. It's a feature-rich app, one might say. And so that's really cool. And I also want to give a mention to, because I've been speaking to some other teams with some more recognizable maybe logos that to you, developers. They are already using .NET and Xamarin. Some of them have done some initial investigation into their transitions to .NET 6, now .NET 7. And we will be working with them to make sure that there is a smooth path for all of them. So this is the Azure mobile app, which is a Android and iOS .NET application. And then the Xamarin Forms app in the middle there, that is the 365 SharePoint admin app. Both get great ratings on the App Store. Highly recommend them if you're not already using them.
Cool.
And then that is the last icon there. I believe it's their logo. If it's not, I just made it their logo, but I pulled it from their website. It's the Microsoft Advertising Editor. So it is actually a desktop application. So I have plans for that desktop application.
So hang on. So you're telling me I can take the 2 hours of cloud knowledge I just used, open up my Azure Portal mobile app, and use a .NET app to provision my .NET services in Azure.
That sounds very good.
That's pretty cool.
Yeah.
That's pretty cool. I'll take that.
It is. So these are just a few of the applications within Microsoft using .NET for mobile and for desktop. And so as we have more of these sorts of stories that we can share with you, we certainly will. But that's not all. There are customers, real life customers in the world doing .NET. So, am I just talking to all these, or did you want to talk to
this one?
I'm
going to do the next one.
Okay.
We got
That's
this.
Right. All right, I just remember. It's a little back and forth. A little on the fly. That was an audible. We just call it an audible.
Oh, I like that.
Actually, it was. I was tried to call it an audible, and she called it off.
Oh.
Technically,
well,
right?
That's because I'm the boss.
So K2 Klima Campaign is a kind of an environmentalist look at your contributions to eco change. So as you saw, the screens are beautiful. This is an in-production .NET MAUI mobile application for Android and iOS. You can go to the Android store in particular and check this app out right now. Becky signed up for an account this morning and created some screenshots for me. Thank you, Becky, very much. Becky's the newest member of our team. Everybody tell Becky hi when you see her.
Hi, Becky.
And then, Maddie.
Yes, this is a very cool application. So our team, our MAUI team, and a lot of the .NET team, and all of Microsoft, but really .NET, is highly distributed. We're all over the world. We have a couple engineers in the Netherlands.
Yep.
And a couple months ago, we found out that the Netherlands, if you're a citizen, you have an app that you use to do basically like two-factor authentication and verify your identity when you go to use government services, to vote, to do all these different things. And that's actually a Xamarin, now .NET MAUI application. So it's called your DigID, your DigID.
Right, it's a great name.
It's a great name, I love it. And it allows you to identify yourself. There's government stuff, educational stuff, healthcare stuff, and every citizen in the Netherlands uses this app. Every single one, and I think there's something between like 50 and 80 million, which is amazing.
Yeah, it's a great app, does its job, does it well, and they're continuing on with .NET 6 and now 7, so that's awesome. I want to spend a little bit more time talking about a customer that we've been working closely with, Civica. They're building an application for modern.gov in the UK, and does UK encompass Ireland, Scotland, and all of the above?
Northern Ireland.
I'm so American, I apologize.
Yeah, you are really American.
I'm working on it, Growth. And so this application helps facilitate meetings like your chamber meetings, your local officials. The public comes in and says, "Don't teach this in my schools," and then so they have to take all the notes, and then they have to stream it virtually, and they have to do all the things now in this era. And so that's what this application does. And I asked Connor, one of the engineers there, and amongst his team, like, why are you using .NET, and what is it you like about Maui? Why are you doing this? Of course, I didn't ask it in such a way that made it sound like I doubted it. Of course.
Of course not.
I didn't want to put words in his mouth. So one of the things that they really do love is this combination of web technologies and native experiences, so they can just leverage more in general. I've given you plenty of time to read the screen. I'm not going to read the whole quote. So here's a look at the app, and so you can imagine your tribunal of six people or whoever
Your
on
council
your
meeting.
council
Yeah.
meeting, all your counselors doing the meeting, and of course people that might be attending virtually, etc. So this is all digital document management. It's voting, video conferencing. Of course, it gets recorded, so you have minutes of the meetings and everything. This app runs it all. So big deal. And now they can take it to multiple platforms, and they love using Maui for this. So it's a very feature-rich app, highly productive for them. I loved seeing the chat in there. I had no idea they were doing chat or the new video conferencing. I think these are features that are yet to come to the existing app, so they're adding on to it. They also said they really like the new handler architecture, the simplified single project structure, because they get greatly increased developer productivity with less time wasted.
That's why we did it.
It is, and certainly we have more work to do there, always cognizant of that, but excited to see more of that coming. Wow, time is flying. And then it's much easier for them to edit native components. It's extremely powerful, so they can get more done with what they have. Maddie, what's happening with Visual Studio?
Oh my goodness. Well, if you've been on any of these social medias today, you've probably seen we had some things ship.
Yeah.
.NET 7, of course, that's why .NET Conf is today, but in my opinion, even better, Visual Studio 2022 17.4. So 17.4 adds support for .NET 7, the same features you've seen before, but even better. We shipped Maui tooling on Windows with 17.3, and we've actually been able to fix over 80% of the bugs that you have filed on us since we shipped Maui GA in tooling in Visual Studio in August.
Yeah,
so I had the engineering team take time off of engineering to pull me that number. I was very, very excited. That means 80% of the things you filed, we are now shipping a fix for in 17.4, which is really cool.
Yeah, I was pretty shocked when you told me that. That's exciting.
Yeah, we're flying. We're flying. But that's not it. We love more than just Windows. We love, of course, a good old Mac as well. Visual Studio 2022 for Mac 17.4 shipped today, and I am really, really excited and very, very proud of the team to announce that we have shipped .NET Maui support in the stable channel, in the stable release of Visual Studio for Mac, which is a long time coming. So we're really excited. Definitely try it out. Send us your feedback again, because as you can see, we're fixing bugs. Yep. We're flying through the bug fixes. So you can also develop other .NET 7 applications, your web, mobile, desktop, and more. And it runs natively on your M series Macs. So we've been seeing people with Ventura and an M2 and all these different things, all the Mac words and Xcode 14, having a great time writing their Maui apps.
Absolutely. I've done my darndest to use the Mac almost exclusively. All right, I want to give you a quick rundown of some of the new features in .NET Maui 7. I am not going to cover them in detail because there are a bunch of sessions coming up. So tooltips. This is where you can hover over any element and expose a little text helper. Ooh. Awesome. Pointer hover, I love this one, so that I can just hover over that button and get my background color to change. Thank you so much. Context menus, you can right-click or secondary click, if you will, on any element and get that nice little menu. You can also use that same gesture, but with the tap gesture, and you can right-click. So I've got primary and secondary. That's how you denote your left-click and right-click.
Interesting.
But it's primary and secondary because who knows?
Who knows?
It's not always right-click and left-click.
Do people who use left-handed mice have
I don't
left
know.
and right-click?
See, Don't know.
That's a great question.
So this is why we chose primary and secondary, so you can decide.
It's pretty good.
Yes, and then this is you.
Of course, yeah. I mean, we've mentioned Xamarin a few times. Xamarin is amazing. We love it. Xamarin has transformed into .NET MAUI, evolved, if you will. And so we know a lot of you want to get your Xamarin Forms apps up into .NET MAUI as soon as possible because MAUI's awesome. And you get to wear these cool shirts, not included.
You don't have to.
Yeah. But just so you know, there will be a whole session by Sweeky, who's a member of our team, tomorrow. But upgrading from Xamarin Forms to .NET MAUI and from Xamarin to .NET 6, 7, and beyond is not a complete rewrite of your application.
Correct.
We just want to make sure you know that there are some changes you're going to make. We're working on documentation. We're working on samples. We've had a couple customers already successfully migrate. And we're also working on the Upgrade Assistant tool, which exists for other .NET workloads today. Mm-hmm. But support for MAUI is in development. You can actually try it out. It does like 50-ish% of the things you might need it to do. Yep. Send us your feedback and we'll continue to chug along on that. But it's not a rewrite.
That's right.
It's not a rewrite.
It's not. So you have time to do that migration, that upgrade. You have support annually. You have 18 months of support for every MAUI release. And Xamarin will soon come out of support, but it's not that soon. It is May of 2024. Cool. So you've got plenty of time. And if you have any blockers or friction points, let us know, because we are working actively on that migration assistant, or the upgrade assistant, and our documentation, which will be coming out shortly. So we want to help you any way we can. There's a lot more content coming up. Check the agenda. Here are day 1 sessions, screenshot, and day 2 and day 3. Lots of great sessions with some MAUI content and or mentions, so make sure that you are there for that. I want to spend the last remaining breaths of this session on a roadmap vision for you.
Well, if you take up the last 7 minutes, then we can't answer any questions, and that's a good thing, probably, for us.
So I want to first do this by recapping. What have we just done? Well, we shipped 6 in May. We shipped 7 today in line with all of .NET. We have unified .NET with a mobile, desktop, and hybrid offering. It's productive development with native APIs and native performance. Maddie, that's not our destination.
Are we going on?
Did you know that?
Are we going to a different island?
This is not our destination. This is only where we begin. This is the foundation for where we are going. So we hear from customers a lot. We need our apps to be where our users are. They might be at a cafe. They might be a field service engineer or a warehouse technician. They might be working in the office or in the house, as it may be, scrolling on their touchscreen tablet. Companies need to be where their users are. And so that's a key reason that we're doing what we do. I want to call back to Satya's quote from the keynote, from another keynote, where he said that it's really about doing more with less, but did everybody notice that he says they're turning to developers? We have a role to play in this, and that is what we're going to do next. We have some specific things that we have in mind, but I want to leave you with this. If you have needs with your company and you're looking for solutions as a developer, reach out to us. Let us know what those are. We have been doing our own research, and I look forward to, in the near future, being able to share that with everybody, because we have some pretty exciting things that we're doing with .NET and the broader ecosystem.
Yeah, we do.
And so, look at that.
Woo!
In time for questions.
I feel so inspired.
Yes.
Oh my goodness. All right, let's see what Matt has in store for us from the Twitter.
All right, thank you, Maddie and David. And Maddie, you hit it right on the head. At the end, I was thinking of the soaring music coming up when David was talking through. Of course, I'm going to let you know of anything I thought of. And this might be a little known fact. It's not to you or David or Maddie, that I started my career here at Microsoft working on Xamarin. So this is a topic near and dear to my heart. And actually, I was a Xamarin MVP way back in the day when both David and I were in our early 40s. Now David's in his late 70s. So that's great. I really love the fact when you all went through the apps that were created for .NET MAUI, and I'm going to interject myself here again because I can't stop talking about myself. I helped with the Hack to Hire app. I just kind of, I pushed the folks kind of in the right direction. I didn't really help as much as kind of just showed where we were going, and yeah, great. So we do have a couple questions coming in from Twitter. So the first one is, a little bit about the platforms. So in .NET MAUI, a collection view with 2 columns are found in iOS and Mac Catalyst and Android. But in Windows, only 1 column shows. Why is that?
Well, that does sound like a bug. So we also, I don't have an 80% number to share, but we have also shipped a lot of fixes. So please try .NET 7 GA. See if that doesn't address your issue, and file feedback. Look at my blog post. At the end of the blog post for the announcement today, outline how you can make an impact and help us improve the platform. Give those issues a thumbs up or some kind of reaction. Add some additional information. That helps us with our querying of issues to know what is impacting the most people. It makes a difference. It's not going to guarantee a fix for you, but it'll certainly help us to provide you with at least a workaround, if not prioritize that bug fix.
Yep. This is me shielding myself from bugs for the day.
Is that what you're
doing?
doing?
It's a day of celebration. We shipped something. I will work again tomorrow. Sunglasses on.
We don't fix bugs, Maddie.
All right, so we have another question coming in, and this is coming from Kai. Can we use VS Code to develop .NET MAUI apps?
You totally can. You can develop MAUI apps anywhere you can develop .NET apps, and you can totally do so in VS Code. Let me take these off while I talk to you. Yeah, .NET, of course, has an amazing command line experience, and so you can create new projects, you can build, you can run, you can deploy, you can do all the things from the command line. VS Code, of course, is an amazing text editor, and there's been a lot of news about C# support in VS Code, so definitely go check out our blogs. They're all over the place, GitHub issues, I'm sure. So yeah, totally. There's an extension you can use. It's called the Comet extension from a former team member of ours who still maintains it. That kind of makes the getting to device part, getting to your simulators or your Android emulators a little bit easier.
It also introduces debugging. So you have the same Monosoft debugger that powers Visual Studio and Visual Studio for Mac is part of that extension. It's an open source debugger that we use. So it's a lot of the same technology brought together, yes, by a former team member, Mr. James Clancy. Hi, James. Hi. But also many others that are still on our team. So if there are things that extension is not doing for you today or you would like it to do differently, again, let us know. There might be an opportunity for us to see what we can do to improve that experience for you.
Yeah, and VS Code is really a text editor. You can do a lot of things with it. You can add a .NET bot as a pet, apparently. Did you see this earlier?
No.
But you can.
Okay.
But the best MAUI experience is going to be in Visual Studio and Visual Studio for Mac, because that's where we have all the hot stuff, the reloads, where we have all your live previews, a whole bunch of tooling things, which you'll see in some of the talks later today and throughout the rest of the week.
All right, so obviously now we're going to have to get the .NET bot to have a Hawaiian shirt on so we can have that swag in there too, but not yet. That's not there yet. We have one more question though, and that is coming from Ryan. Are there any resources that you recommend if you run into issues with MAUI or just to learn MAUI more in general?
Yes. Yes, there are, Ryan. Thank you for asking. First and foremost, if you hit a bug or if you have a feature idea, there are 2 ways you can file it. One is on GitHub, .NET/MAUI. Generally, we use the GitHub for things for the SDK, right? Like my collection view is only showing 1 column. That's a good GitHub bug. If you're in Visual Studio and you're having an issue with Visual Studio, or if you have an idea for a way to make your development life easier, you can go to Help, send feedback, report a problem, or suggest a feature. So that's how you get your voice out there with once you're in the product. But to learn it, we have a ton of resources.
Sure. We actually just published all new documentation for many of the 7.0 features today. So those went up live this morning. We have Learn courses for some of the more beginner-related things. Also for specific issues, if you're like, how do I accomplish X, Y, Z? Check out the Q&A forums. You can post questions, of course, search for anything that's there previously. Those are actually monitored by some of our support staff, and they may be able to answer that question for you. And you might actually be able to get an answer on Stack Overflow too, so don't hesitate to engage there.
Cool.
Great. Maddie and David, thank you very much. Always loved talking about .NET MAUI. Always love hearing about the state of client development here with .NET 7. So coming up, we now have Shane on Teams to bring us through desktop development with .NET MAUI. Shane, over to you.
Hello, Matt. Hello, MAUI developers. How are you all doing here? So we've been talking about a lot of the stuff that's been released. Now I am here to get into the gritty a little bit, show you some of the new features that have been released. I have a nice little app that I put together to demonstrate these as well. So let's just dive right in. .NET MAUI for .NET 7 general availability. Yay! Clapping sound. So there was, as Dave had mentioned on the thing we did, there were a lot of usability improvements, but we also were able to sneak a few new features in that we're all excited about. We added the foldable APIs. So in Xamarin Forms, that was the dual screen NuGet, but now it is coming at you as the foldable NuGet. So Craig Dunn did a wonderful job porting all of those over to MAUI concepts. And so now you can use the two-pane view, and you can use, you can basically reach into the APIs now on any sort of foldable device. So it's nice because now it's based on the Android bits for that. So it works with any Samsung foldable or your Surface Duo as well. So yeah, give those ones a try. Window positioning, which gives you a lot of ability to interact with the window, set positions, move it around. And then we also added tooltips. So they give you some nice added contextual information, context menus. So we're going to kind of run through these in more elaborate detail throughout. So just kind of touching on what we've added. But yeah, context menus have been added to Catalyst and WinUI. So you can get the nice little flyouts that pop out, and you can add actions to things. There was a number of accessibility improvements because we're constantly iterating our accessibility and monitoring and making sure that we are staying accessible with each release. Another very exciting thing, pointer gesture, which has also added some pointer over Visual State Manager features, which is very exciting. So you can add some really cool styling. And then we also added secondary click and some position data. Position data. So now if you've ever wondered, now that I clicked there, where did I click? Well, you can ask the system. It'll tell you where you clicked. Pretty exciting. So context menus basically are attached to a single element. They display secondary commands. You can invoke it by secondary clicking or an equivalent action. They are added through an attached property, flyout-based.context flyout. So we used the WinUI API for this one, just to kind of keep things familiar. All the types of menus that you can add are the same as you can add with WinUI as well. So you can add the flyout, you can add a flyout item, you can add a separator, and then you can add like a sub item if you want sort of like sub views, which is exciting. So you can kind of see how this sort of surfaces. On the left here, we have Catalyst. Pretty. And then on the right here, we have WinUI. Context menus. Tooltips. So tooltips, the lesser version of a context menu, just gives you nice information on, say, images, or if you just need a little bit more context on something, we have tooltips. So those surface out in a number of ways. Those are on all of the platforms, which is nifty. So basically, you can hover over with your mouse on either WinUI or Catalyst, and you get this nice little pop-up. And then on Android and iOS, you touch and hold, and then it pops up. So we will see that in the chat app coming up here. So that is also added via attached properties. So currently we have only the text property on there, and you can apply it to any layout or elements, and it'll give you a nice little tooltip. So here I am adding the tooltips to the shell flyout items, which we will see in the chat demo. Pointer gesture recognizer. So this is a very exciting one. I know a lot of, especially desktop users, were very excited. We're saying can't really do much if you don't have a pointer gesture. So now we've added a pointer gesture recognizer, which has all your basic entered, exited, and moved. So as you are tracking on As you are tracking on Catalyst, Android, or WinUI, you can just move the mouse over. As it enters something, the gesture will fire, and you can start getting information on where the pointer's at. Alongside this, we also added the positional data, so we can kind of see the APIs for that here. So Rachel Kang did a great job adding all of the pointer gesture features across all of the platforms. So for the pointer gesture, and this, it's a similar API for the tap gesture. Essentially, you can just, you use get position, and then you pass in the element that you want sort of the relative position to. So in this first example, the sender is on your args. So this is basically giving you the position relative to the view that the gesture is on. And then get position with null gives you relative to the window. And then you can pass arbitrary views into it, and it will tell you the position relative to that arbitrary element. So you can see here with this very fast demo going, you can see it kind of showing the positions. So it's hovering over this label in the middle, which has the gesture, and you can see that the positional data is updating. So you can see here with the window, the Y has a bit of an offset. The X's are all the same because everything's lined up. And then here's the position relative to this label. You can see it's a negative Y position because it's above the label. So the pointer gesture was exciting because that was a precursor to pointer over visual state, which is very exciting. I know David was super excited about this. He kept asking, where's my pointer over visual state? I think it's part of his weekly reminders to bug us about pointer over visual state every Monday. I'm curious what he's going to update that with now, but for now, he was happy last Monday. So pointer over visual state. What can we do? VSM. Who loves your VSM? Here we go. Normal. You can set the background color. This is your normal background. And then you can set pointer over. Easy as that. And look what you get. Ooh, colors. Isn't that neat? Look at that. I'm just moving the pointer over it, and it's changing colors. It's amazing. All right, tap gesture recognizer improvements. So along the lines with the pointers, we have tap gesture. So we added button mask. So this is still on the lines of desktop improvements. We have a, you'll notice this mask, which came from the click gesture recognizer in Xamarin Forms. In Xamarin Forms, the click gesture recognizer only worked on Mac OS. It wasn't wired up anywhere else. So we got rid of it, and we just coalesced it around tap gesture recognizer. So basically, it's a flag. So you can just, OR together what you want the gesture to recognize. So if you want it to be secondary, you can just do secondary, or you can do secondary or primary, and it'll be both. The default is just primary. Tapped event args. So tapped event args are on the tap gesture recognizer, and that's exciting now because you can get the positional data from the tap gesture recognizer. So basically the same APIs. Here's a very exciting demo. Ooh, tap. See, over here, I'm right-clicking this label. Over here, I'm right and left-clicking. So if you look over here, you'll see when the mouse goes over it, there's a second when it doesn't do anything. That's because I'm left-clicking and it's not doing anything. So it's demonstrating that only secondary click works. So just imagine there's a little bubble popping out and nothing's happening because it's working. So tap gesture recognizer improvements. So this one works on, let's see, right-click works on, yeah, secondary click, sorry, works on Android, Catalyst, and WinUI. Let that marinate. All right, foldable support. This is when the slides get fancy and the foldables get exciting. So foldable support, this is the, we'll demo this on an actual Duo simulator here in a second. And you'll see the different pivots. So basically this view is using a two-pane view to power the ability to work across the I don't know what the official, forget what the official name is this now, the divide, the chasm, the black abyss. I don't know. It to work across that, the middle part aspect. So here we can see essentially, so as you resize, these properties will update. You can subscribe to size changed on the window if you're curious to track your window size changes. So you'll see where I'm using that in the list details here in my repository. Yeah, so that video is exciting. Nice Windows API. So thank you, Matthew Leibowitz, for putting all those APIs together. I know that was a big effort, but it's cool. Look, you can do like the centering. It's neat. I know that right when we got multi-windows, everybody wanted to indicate where to put them. So there you go, multi-windows. All right, and with every release, we always want to be improving the accessibility story. So I definitely wanted to highlight that accessibility is a focus on every single release. Thursday, I'm pretty sure it's Thursday, Rachel Kang is doing a presentation on accessibility, so make sure to check out her presentation. If I remember correctly, it's Thursday. So accessibility updates. We've closed around 35 accessibility bugs, that's fun to say, accessibility bugs in the last period. There was a heavy focus on the Windows desktop experience in this last push. We had a recipes app that we've built, which is actually on Rachel's GitHub. If you go to Rachel Kang's GitHub, you can see the app that we've built that we run through all the accessibility testing. So there was a big focus on Windows issues, and we cleared up a lot of we made the default experience with Shell very accessible, which is super cool. So basically, all you have to do is add your flout items, and boom, they're accessible. So this is essentially what the narrator is going to read out. Some honorable mentions. These have kind of been around since Net 6, but I just wanted to kind of touch on them because I think they're very exciting within a multi-window world. We have the menu bars. We did add the menu flyout separator. That is one new thing that Elon added. Ooh, menu separator, pretty fancy. And then scope services. So a lot of the services stuff is going to start really coming into play with Net 7, and then especially with Net 7 is going to be a big one where we're sort of shaping the way users want this stuff to work. And then, and then we're going to have some. It's going to be really cool. But you can also do really cool things now in Net 6 and Net 7, which I will show you in the sample. So here is the menu bar. Pretty basic. Look at that. There you go. Menu bar. So the